Hello, hello. Is there any voice from there? Or hello, hello. Hello, hello.
I hope everyone managed to get some coffee on the way. Yeah. Good. Yeah, I think we'll get started, right? As the other people were still on the way, will be coming. I cannot hear myself. Yeah, on the way. We go. Okay. Good morning, everyone, and welcome everyone to Montreal if you're flying from abroad, and welcome to Polytechnic if you're coming from outside of Montreal, and welcome to Amphitheatre in Alama if you're from Montreal. So welcome to Montreal, welcome to SEMLA. This is the 7th edition of SEMLA. So we have been running this since 2018, and I hope you have been enjoying the events over the year as much as we have been doing. And we're very excited to welcome you here at Polytechnic to discuss these important topics about the engineering of machine learning application. So what is SEMLA, right? I have this usual slide. If you have been attending this over the years, I guess you may be bored of my slide for now. Oh, I'm already at the end. Last slide. Let me just get it this. So SEMLA is software engineering for machine learning application. So it's now we have actually a formal group, which is also called SEMLA. working on trustworthy engineering of AI systems. So it's a mix of software engineering practices for systems which are now mostly composed of AI components, right? So when we started this, it was in 2018. At that time, machine learning was getting out of labs, and then we were observing more and more applications being deployed in production with machine learning components, and the practices around how to handle this specific nature of these data-intensive applications were not optimal at the time. So that's how the ideas of bringing together this community of both experts in software engineering, we have 50 plus years of expertise in building software systems, an expert in machine learning, learning systems, different paradigm of learning, coming together to getting a deeper understanding of what happens at the intersection between these two problems. So SEMLA really aimed to tackle this question: how do we engineer machine learning applications with the best practices to ensure that they are trustworthy, that we can provide guarantee on their behavior, that they can scale, that they can be efficient, that we can deploy them in a way that provides the services to the level that is expected. So all those questions have been the core topic of SEMLA over the years. And the landscape has been moving, right? So when we started, it was a deep learning era, where deep learning was all over the places. And now foundation models, which are also deep learning based, are disrupting both the machine learning landscape and the software engineering landscape. So bringing together and so facing new additional challenges, which means SEMLA is even more relevant today than before. So this year editions have been organized by this team, mostly. I would say Max, Mo, Bentley, Henley, Agravan, Armstrong, and Zorin have been doing all the legwork so that we have a very exciting event. I'm just taking all the credits. Anyway, so please clap for it. And we have an army of volunteers. You'll be seeing all through the way the early our students were actually doing on the work in the background, making sure that we can have a very exciting events. And we can do this because we have, from day one, we always had the generous support of these three institutions. So our department, we have our department chair. We will give us a few words in a few minutes. Polytechnic Montreal have been a very strong support of this event from the beginning, providing resources that allow us to run these events the way we wanted to do it at really low cost and exciting for everyone, providing the best experience for people to discuss this topic. And Ivado have been central to this from day one. And over the years, we have been able to attract these gold sponsors. We have been able to chip in and provided support to support the students, private grants, posters, and so on. So we're very excited and we're very grateful for this support. So please, a big clap for this. So now I will invite my department chair, Professor Nicolescu, to give us a few words. And for the department have been a pillar on this adventure over the years.
Thank you for the introduction. It's a great pleasure and honor for me to be here with you and welcome to this great event. It's an event that it's helping all of us for the Department of Software and Computer Engineering. It's an opportunity that we wait each time, and we are very happy that this is the seventh time for our students that have access to learn. It's great. So this is why I would like to thank you, all the speakers, all the attendees, all the organizers, all the contributors. I think it's a nice occasion to learn from each other, to get inspired, to make networking, of course, and to learn to make new projects and to make this field to advance, which is of course great. Also, I know that during this today, we will delve in the field of software engineering, software development, intelligent system, and these are terms and axes that are really strategic for Polytechnic, for our department, and I think they answer to a lot of questions and demands from the society and from our partners. So again, thanks a lot, and Welcome to all the attendees, the speakers, and the organizers. Thank you a lot.
Thank you. Thank you very much. So our VP research, Annie, she really wanted to come say hello. So at some point during the day, she will still come in and say hello to everyone. So I just wanted to put a note on this. So what is SEMLA 2024 this year? Well, we have a packed room. It may not look like it yet, but we have more than 200 registrants. So you'll be having the opportunity to mingle with a lot of people at this point. And as you can see, and we're very proud of this, half of it is students, right? So this event, it's meant to be a platform for us to discuss this topic and us train the next generations, right? We want to upskill the students so that they can actually help solve this problem and tackle this problem. So I'm very happy when I see the distribution like this. We also have a very healthy share of industry participants in the room and postdocs and research associates. So it's a mix, and I really look forward to the discussion. And I encourage everyone to take the opportunity to really interact, reach out to the others, and discuss your ideas on the topics and so. But that's what's the program? Talk about the program. Oh, hey, you should talk about the program. Okay.
She's the program chair.
Yeah. So Hang is our program chair, so you should talk about the program.
Thanks to all the speakers and panelists. So we have a very packed program. Basically, we have 4 sessions. The first day is an industry track, so it's more industry oriented. We have 2 sessions, and one in the morning, one in the afternoon. So for each session, we have a panel, and the thing of the panel is aligned with the session theme. Okay, and yeah, the first day we have 6 talks, 2 panel, and the second day we have 6 talks in research and also 2 panels. And today, after the afternoon session, we have a reception and a poster session. So that will be in different building. You will see the details later. Okay. Yeah. So these are our speakers and panelists. Please give them a applause. So you can also participate in our program basically. So we have 4 panels. We invite you to ask your questions that you would like to be answered or discussed during the panels, and also you can vote for the questions you want to be you want to see. And for example, here because we have 4 panels, it would be easier if you can add the session number for when you post the questions. Here's an example. Okay. And we will keep this QR code available on the last slide. We will show for a long time. Okay. That's it for the program, I think. Posters.
Thank you very much. We also have a fantastic poster session. Mo, please, you want to explain the rules of the game? And with the generous sponsorship of our sponsor, we have healthy prices for the poster session. So, yeah.
Okay, so we have also a nice poster session that you will be able to participate in. So we received many posters, 42, like 44. I think you've been in contact with Bentley, like did fantastic job in all these posters. Also putting the full site where you can vote for the different posters. So the poster session will be at the same time of the reception. So you can enjoy food, have drinks, and at the same time, don't forget to vote for the posters that you like. We have generous sponsorship from different, as you can see, from Ericsson, from Bank National, from SEMLA also, and Evado. And we have generous prizes this year. So we have 3 prizes: the first prize, second prize, and third prize that you will be voting, and based on your vote, these results will be announced. And then the moderators will judge the what we call platinum prize, which is $300. So yeah, try to vote and show support for the posters that you like.
Thank you very much. Okay, some practicalities, Max.
There, I'll get the boring stuff out of the way so we can keep going. So as you already know, badges are right in front in the little pavilion across. You can also get breakfast and coffee breaks in that room. So whenever we have a break, even the afternoon break, you just go across, the food will be there, the coffee will be there. There's also tea, some drinks. But unfortunately, the room is too small to hold lunch. As you can see, we're already about half full. We have quite a few more participants that should be coming. So lunch is in this building on the first floor. You can follow the army of black shirts. They will guide you there. Don't worry, you won't get lost. And then one of the important things is technically we're not allowed to bring food into this room. I'll keep my eyes closed. If you haven't already seen at the back of the room, there are some printouts that have been hanged on the walls. You can scan the QR code that should give you access to the Wi-Fi immediately. If not, the Wi-Fi ID, the SSID is SEMLA2024. And the password is, that's VNV, so and ops for AI. The password is also on the sheets at the back of the room, so you don't have to jot it down really quickly. And like I said, there's a QR code, so if you have your phone, you can just scan it. The emergency number for the school is 4444. Ideally, no one needs it, but there are phones all around. If something happens, you can use that. As already mentioned, we will have a poster and reception session. The poster and reception session is in a different building. The building is linked underground from this building. You do not have to exit any of the buildings to get there. There again, the army of black shirts will guide you to the next location. And I hope you enjoy. Don't forget to vote for the posters. If you have a poster, please try to set it up during lunchtime. You can ask me or anyone in the black shirts. We will guide you to the location so you can set up your poster.
Okay, thank you. Thank you very much. So we're almost there. We will be starting very soon. So don't forget to use our hashtag tweets, make noise, share what the awesome things you're saying in the room and what we're doing. We also been streaming the events. It wasn't announced before, but we always do that. We have these secret gifts that happens on the first day of the event. So they will be streaming and people could be following from remote if they couldn't manage to be in the room. And if you see something you like, you want to share, but tweet, and you can use our hashtags for this. So what do we expect? Well, I personally expect that we have a healthy exchange of ideas, and I hope you take advantage of this. We network, so we keep building this community and keep growing it. Discuss as much as possible, but also more importantly, have some fun. I think that's a very important component of this type of events. So that's a bit my expectation. And welcome, I think that's it. And thank you very much for everyone who have been doing their best working. I think it's a year effort to reach to this day, to making sure we can have this event. Without further delay, I would like to get us started. So invite the moderator of the first session to come introduce our first keynote speaker so we can get started. Okay, more. So welcome, thank you everyone.
So, hello everyone again. So my name is Mohammed Hamdaka. I'm assistant professor at the College of Montreal here, and I'll be chairing the first session here today. We have an exciting session about privacy and security of AI and foundational models. Let's welcome to the stage our first speaker, Dr. Nigar Mazda. She's here. Okay. Great. So so Dr. Rosta Mazda is a staff research scientist at Google Society Centered AI team, where she studies the social impact of machine learning technologies and evaluation systems. Prior to joining Google, she was a research scientist at Element AI, focusing on efficient sampling and labeling approach and multimedia and computer vision problems. Dr. Nigar has PhD from the University of Toronto, centered on video understanding problems. And during her PhD, she had 2 years internship at Mela, where she worked also on attention mechanisms for videos and for captioning generation. And well, she is a co-founder of Women in Deep Learning and active member of society. So welcome, Dr. Nager, for the talk. So she will be telling us about the beyond the machine learning models, from plane crash to algorithm farms. So welcome to the floor is yours.
Just a second, sorry for the technical difficulty. Hello, everyone. I'm Nega Rostamza, the research scientist at Google Research. And today we'll be talking about assessment of machine learning systems, and specifically with regarding to algorithmic harms. And I'm super excited to be in this really amazing conference. Thanks to the organizers. So my background is in computer science, and later, more specifically, in machine learning. In these fields, we often hear the mantra, move fast and break things. It's even a book title and a former Facebook motto. However, in critical and important problems, this approach is not necessarily a successful one. Have you heard the same motto from a safety engineering team in aerospace or in a nuclear plant? Should we fly the plane, and then if it crashes, we assess the issues and improve it? Obviously, for such high-stake problems, that's not a good idea. Machine learning is also addressing a lot of high-stake problems, and algorithmic harm should be predicted and anticipated in advance. I will be briefly talking about our two recent Kai and AIS papers on the applicability of safety engineering tools for responsible development of machine learning systems, and specifically mentioning a case study for text-to-image generation applied for creative domains. Machine learning algorithms are being continuously integrated into various products and application areas. Anticipating potential harms of these algorithms earlier into the design and development process is non-trivial, and it's a very challenging task. Safety engineering is a long-standing field that has dealt extensively with identifying and managing harms, hazards, failures, and risks for technologies during the last 100 years. Frameworks from safety engineering have been developed and used extensively in safety critical systems such as distribution of electricity, drug, medical device development, nuclear plants, and aerospace. Safety engineering tools and frameworks provide analytical processes for connecting system design to potential harms through understanding for failure and hazards. For example, these tools can map how and when a small crack on an airplane wing can lead to catastrophic failure of the full plane. In our study, by conducting semi-structured interviews, we try to answer these two research questions. First, how the ML practitioners currently identifying and assessing social and technical risks and ethical risks and the current challenges. What are the current challenges that they are facing and the gaps that they are facing in their practices? Second, what do the ML practitioners think of these safety engineering frameworks and how these frameworks could be employed to predict risks, harms, hazards, and failures, and in general for social and ethical risk management? There is a rich body of work that has investigated potential ways of anticipating and mitigating harms from ML systems. These include critical epistemological perspectives, design methodologies, and a range of recently published toolkits and frameworks. Surprisingly, the conversation between the fields of safety engineering, which is a very long-lasting field, and responsible ML development has been very minimal. Some scholars in the responsible machine learning community have hinted a potential use of safety engineering framework for assessing and mitigating potential social and ethical risks, as well as establishing traceability and accountability practices. The two frameworks that have been discussed primarily. Oh, thank you. Should I start over? Some scholars in the responsible machine learning community have hinted at potential use of safety engineering frameworks for, as I mentioned, assessing and mitigating potential social and ethical risks, establishing traceability and accountability practices. And the two frameworks that have been discussed primarily for applications of machine learning systems are FMEA and STPA. These two frameworks are some of the most successful and widely used frameworks across safety critical fields and industries. We also consider FME and STPA as the two techniques provided a complete and different approach to analyzing failure and hazards. They basically have very different structures, so they might be we kind of assume that they might be complementary to each other. Before explaining the findings, I will take a couple of minutes to give a quick overview of these two safety engineering processes. Is that voice good? FMEA is a traditional engineering risk assessment practice that looks at how a system could potentially fail, what is its effect, and the causes, and how it could be controlled for. For example, we could break down a car into its subcomponents and look at how each function of the components, such as the tire, could fail. We then look at the effect, cause, and control for this particular failure model and score these three elements on a scale of 1 to 10. The risk priority number is then calculated from multiplication of these scores. An FMEA is done by safety and system experts, and it contains thousands of rows of failure modes for a complex system such as a car. It is a relatively new technique. Taking the systemic theoretic perspective to our safety, it maps elements of a system, their interactions, and examine potential hazards, which means like sources of the harms. Modeling at the system mean to capture emergent phenomena that are well described only by system interactions rather than individual components and behaviors. For example, if we were to perform an STPA on a new surgical device, we would start by identifying the high-level losses, hazards, and control for the full system. We would then go on to a control structure for the system to outline the interactions between the various human controllers, such as surgeon, the patient, the automated controllers, such as a new surgical device. The control structure outlines bidirectional interactions of control action and feedback between a controller and a system. We then go on to analyzing how the control actions could be unsafe by thinking through 4 different heuristics. And identify the potential causal scenarios for each unsafe control action based on the control structure. And the 4 elements that I mentioned are listed here. Sure. And we identify the potential causal scenarios as. Let's go back to our first question. For investigation and semi-structured interviews, we identified informative sub-themes as current definitions that exist, evaluations and mitigations, and finally, challenges for social and ethical risk assessments. Our finding resonated with some of the recent work studying operationalizing of responsible AI research. However, the key finding from this step was that social and ethical risk assessments practitioners are done at a very ad hoc level, and there are no systemic or standardized approach for this type of assessment. When it comes to research question 2, experts agreed that overall STP and FMEA-like processes provide very sound structure, as illustrated by these 2 codes from our study. Like one researcher said, there are definitely cases where explicitly defining failure modes, for example, using an FMEA, trying to have a sense of what the potential causes are and how to mitigate them is a really useful framework for machine learning systems, and one that has not been terribly well formalized until now. And the other researcher states a systems theory approach, as using STPA, is very useful. It helps us to understand relationships between new pathways of harms and allows them to think about the multiple points of intervention. In fact, some of the experts emphasize that they currently use FMEA-like processes, but not much of like STPA-like systems. Here is the perspective of experts on FMEA. When they were asked to consider the COMPASS risk assessment algorithm as an example of criminal justice court to find the failure modes. For the FMEA process, experts stated that an FMEA process is intuitive to walk through, has similarity with some of their current evaluation practices. And many of the participants emphasize that effect of failure mode is different on different stakeholders. And it's very important to clarify effect on who, particularly for ML systems that are deployed at large scale. So it's very important, like they identify it's very important to understand who is impacted and how, and appreciate the link between controls and effect, and cause it can allow streamlining the risk assessment and mitigation practices. And all the experts stated that there are a lot of existing knowledge gaps and uncertainty on identifying and measuring effect, cause and control for machine learning systems due to their complexity and novelty. When it comes to the STPA process, practitioners mentioned that starting from losses is very intuitive and user-oriented. Some emphasize that they already started from thinking about the user, and therefore the STPA is very intuitive for them. When it comes to scoping the control structure, the practitioners and participants shows and suggested 2 primary approaches. They either scope the control structure around internal company processes involved in developing and assessing ML systems, or they scope the control structure to outline human ML interaction scenarios. And finally, when thinking through unsafe control actions, a number of practitioners emphasize that unsafe control actions could be mapped to design choices and decisions, and appreciated the heuristic of thinking through how each control action could be unsafe. Now that we saw how FMEA and STP are being developed for these problems and the expert perspective on these tools, here I'm going to briefly mentioning our second paper at AIS conference, which is a case study of applying the safety engineering techniques and tools, FMEA and STPA, as we discussed, for identifying potential social and ethical risk in text-to-image generative models applied specifically for creative industries. Typically, FMEA and STPA are conducted by systems experts and safety engineers who are working in a company. This analysis have in-depth knowledge of the systems and the state engineering processes. Considering that both FME and STPA are conducted by the authors of this paper, we actually needed to interview experts who work on the development and deployment of the systems, and also educate ourselves about the stakeholders involved. So this is actually very necessary in order to divide the system into functional components or steps. In the case of FME, and losses and constraints in the case of STPA. In our case study, we collected 3 different sources of data for conducting FME and STP analysis, including workshops with artists, expert interviews with text-to-image model developers and evaluators, and secondly, research on text-to-image model literature. So FME could be applied to various scopes of analysis that requires a different set of information. Scoping and machine learning system for such an analysis is very non-trivial. A machine learning system can be divided into component parts based on the information gathered from interviews with text-to-image experts and workshop with artists. So we came up to 3 different scopes. The data processing, which is very necessary scope for creating training data sets, and almost all machine learning systems, data-driven machine learning systems, how a text-to-image model is integrated into a production environment along with other machine learning components and models. And finally, how an artist uses text-to-image models as part of their practices for creation. And after conducting FME and STPA for these 3 scopes, we examined 2 key elements for each scope. First, could any of the identified failures and hazards lead to social and ethical risks? And second, did our analysis discover any new issues and failure cases that haven't been reported or identified with other types of approaches and methodologies? We then reflected on common themes and lessons that we learned that is appeared across all these applications and when we are using these systems. So, as I mentioned earlier, we identified 3 scopes and examined the future loss hazard using FME and STPA. FME structure is identical across all the scopes, focusing on understanding the functionality that's prone to failure, failure modes, effect, cause, and control. First, on the data processing side, like this slide is related to data processing scope. So, in our application, we bound the data processing stage to start from the identification of one or multiple source data sets and end with the creation of training data set ready for model development purpose. In this scope, we do not directly analyze the steps involved in how the data sources were obtained or who was involved in data collection processes. These are definitely very important processes, but they were out of scope for this specific study. The focus is on how the data sources are processed. So we identified on the data side, and we considered and identified 3 different stakeholders, key stakeholders: software engineers who prepared the data sets for training, responsible machine learning practitioners who provided guidelines on what should and should not be included in the data sets, and finally, lawyers who consult on privacy and legal requirements of the data sets. The software engineers collaborated closely with the practitioner responsible for developing the model. Lawyers provide large requirement and legal requirement for intellectual properties and privacy reasons for training data sets. And machine learning researchers and collaborated with the product teams. For FME on the data processing phase, we identified 5 steps. So basically 5 steps that I'm saying is like 5 different functions to lead to failures. Like filter for record identified as containing sensitive data as prone to failure, filter for non-English data, filter for adult content in images, a filter for text associated with adult content, and finally excluding low text image semantic alignment. We identified 3 to 5 failure modes for each of these steps. Oh. Technical difficulty. Oh, we are back. I think like I talked a lot, so that's why. Where I was. Okay, so we identified 3 to 5 failure modes for each of these steps, and which is resulting into 22 failure modes for this scope of analysis, like for the data side. And like as you see here on the first step, filtering sensitive data content, like just put the filtering sensitive data content as one of the identified steps, and the rest of the FMEA systems. So we identified 6 failure modes due to underperformance, which means some sensitive data is not captured. 6 failure modes due to overperformance, like English data is filtered alongside with non-English data, or 6 failure data failure modes due to loss of performance, like low text image semantic alignment is included of the filter function and so on. 12 of the identified failure modes have clear social and ethical implications, which is like one of the main goals of this study to understand and investigate. And for instance, underfitting on the source data. No concerning like SCP. SCP, on the other hand, starts identifying losses. To identify the values of losses associated with these scopes of analysis, we reflect on the information gathered from the interviews and the workshops to understand stakeholders impacted by the data processes stages. Artists emphasize that the value of fostering creativity, serving a diverse audience, accessibility of artistic mediums to a diverse group of artists as one of the areas, and then efficiency in the creative processes, the preservation of artist reputation and identity as another aspect. And the developers and evaluation of the text-to-image models emphasize the values of diversity, importance of serving a diverse audience and users of these models, and the importance of protecting their teams and their company's public reputation. From the key values brought up by artists, software engineers, and responsible engineers, the practitioners, we formulated the following losses. So the losses are listed here: loss of creativity, loss of diversity, loss of accessibility, loss of efficiency, loss of quality, and loss of reputation. And moving forward, also like on the hazard side, as you see here on SCPA for data scopes, it includes 2 organizational harm and 2 organizational controllers, which organizational and like /humans controllers, and 1 automated controller. We selected the responsible machine learning teams and product teams as human controllers because they can make the key decisions in the data processing scope. For this analysis, we assume that responsible machine learning team is in charge of determining the parameters for a good training data set and identifying key ethical and legal considerations. The product team is responsible for developing the models that underpin the text-to-image model for artists that are using these algorithms. We selected as filter data an automated controller to reflect on where all the automated filtering operationalize and take place. So that's basically the system. So I'm not going into the depths of all details of for other like part of this like ML pipeline. So I wanted to go into the depths for just the data side. But this would give you a glance over how do we treat model and product integration and how we are going about understanding the type of failure modes, hazards, and risk basically using both FMEA and SCPA. And I will summarize how we can actually, like, what are the things that we can get from each of these systems. And then the most interesting scope that we use is the end use for example, for creative practices, for artists who are the users of these technologies. We specifically, go to the paper, we actually use the community of filmmakers who are using these technologies and video content creators. And we discuss over the things that can happen from their perspective and them as controller in the SCPA side. And of course on the failure modes as well, FMEA as well. So to conclude, we learned that basically safety engineering frameworks with a long history should be exploited more under responsible machine learning development. Existing and well-established safety engineering frameworks can serve to analyze effects, hazards, harms of generative models and beyond this type of systems. And a systemic approach modeling the interaction and functionality of the systems is needed to uncover many issues that are otherwise hidden while only assessing the models. Just if I want to summarize the whole talk, I would say that there are many well-established fields. Like here, I'm talking about safety engineering community, but there are many different fields that we can learn from on the machine learning side. You're all software engineers, so I wanted to mention as well that there are so many practices that we can actually learn from the type of testing and assessments people in the software engineering community are doing. And machine learning community is very behind these processes. Even the type of unit testing, if we can exploit them for example, or integration testing for a system which is a machine learning system. These are the things that are missing pieces in machine learning assessment. We always see everything from the model perspective in machine learning, which is lacking so many fields, expertise in so many fields that are very closely associated with machine learning, but we are dismissing them. So this actually work was conducted in collaboration with my colleagues and amazing student Shalala Rismani who is a McGill student, was leading these two projects as an intern when she was doing her internship at Google. And thanks to you all.
First, thank you for the exciting talk. So we will have 2 questions. Anyone have a question about the presentation? Well, I can start with questions about the work that you have. So it's very interesting, to have this balance between safety and how much support we have in terms of tooling to build and, for example, to certify for safety. It's always, we have these frameworks that people propose and try, but when you want to put this into practice, you want some maybe systematic way to help people apply these frameworks. So is there tool support that available now that you recommend, or how we can take this into practice?
Thanks for a very important question. So we don't yet, these are basically with these 2 studies, we kind of investigated that people are feeling that there's a gap here for this type of assessments. And we should learn and do this type of work, but there is no tooling. There is no there is no standardization of requirement. You need to actually do this system assessment work in order to be able to send your product or basically work on these problems. So these are the things that are lacking, and I hope that in the future we will see this kind of tools to actually easing these processes and systems, and definitely it would also help with all the stakeholders, even machine learning developers, even companies and industries who are using and developing these kind of tools, because that's kind of, we identified as one of the things, this reputation, that's a concern. So that actually could be also well addressed with this type of having these tools to make sure that the product is safe and sound and it's respecting ethical considerations.
Thank you for this great presentation. If I understand correctly, you are using like even three models as one of the components of your approach, right? Like even three models or event diagrams as one of the components of your approach, right?
I'm not quite clear, but what is
So,
it?
so one of your approach is based on the FMEA.
Okay.
And even state diagram.
Sure. Okay. Yeah, I got it.
So these diagrams, these models are based on, the required extensive expertise, right?
Exactly. Yes.
So, and in some cases, because I was using these techniques in the industrial processes, and in some cases the human is not sufficient. So we need to take into consideration the historical data. So the best thing is to have like combination data-driven and words. So my question is, if you try to use like data-driven techniques to enrich this moment?
We have. Actually, I think it's a very good point that you mentioned. So we haven't, but so two things. One of them is that like if you make from the data-driven models is like automatic detection of failures or like automated, for example, like red teaming. If we have this type of approaches, so that's something which is handled maybe like with these machine learning experts. When we are going to this like type of like having this information from historical data, that's actually something that we haven't considered, but I think it's a very good idea because sometimes, like as you mentioned, like we need very deep expertise to understand. Like, I mean, we interviewed people because we didn't have all the components of the models and we didn't have all the knowledge. And probably all the people that we interviewed don't have access to all the historical data of failures. So that's a very good idea to actually be able to use this kind of systems. But then we should also be careful about the type of harms that they could actually additionally introduce. But I think it's a very good direction to consider. For sure, yeah, that would be amazing. Thank you so much. That's very good.
Just a quick one. So thanks for the.
Thanks for the very interesting talk. So I totally agree with the message, right? We need to use safety frameworks. That's already well established somehow. Personal transparency. I just wonder from your perspective, this work ways where is information model of different models that's potentially safe substance. So is this a practice that is in-house being used? Like what is the perspective of the industry from your opinion?
So some of this, I mean, I'm not on the development or deployment, so I may not have like all the information about the things that actually going into practice right now. I'm more on the research side. So these are kind of like practices that we're exploring and we are encouraging the companies, including Google, to use this type of services. So I assume that like some of them are already in practice, but I don't have like the knowledge about this.
For sake of time, maybe we move to the next presentation. But let's thank Vega again for the presentation. Well, I was talking about relation to like your talk
you so much.
Excellent talk. Thank you. So yeah, we have Anil from the that will provide some message for the audience.
So Annie is our director of research. She can share a bit few words.
Thank you so much, and everybody. So, just a quick word on behalf of Polytechnique de Montréal. My name is Annie Ross. I am the Deputy of Research and Innovation here at Polytechnique. Very, very happy to see all of you this morning. Thank you for coming. I hear there's about 200 people registered. That's really great. I'm sure that we will have a lot of very, very good talks and discussions over this thematic verification, validation, and operation of AI systems It's extremely important, and I just heard and the presenter here talk about safety. We could also talk about robustness and everything that's related to AI applications, good AI applications. And actually, this is closely related to one of the major access development here at this technique, who is a founding member of the IPADO and recipient of a very important grant from the federal government, a $125 million grant to develop good AI, and I need to look to my notes to make sure that I say this properly. So the grant is in English because I'm used to saying that in French. R3AI, so AI of course, and R3 for robust. So AI that relies on some models and applications. The second R is reason, AI that is explainable, causal, and modular. And the third R is responsible, AR that is ethical and inclusive. So all that you're doing together is along that path. It's extremely important for everybody to make sure that our future is a good future. So we're very happy to have you, to host you, to support this symposium year after year. And I'm always glad to come and see you. I have done for the past 3 years. And I would like to thank the organizing committee. First of all, I would say who always invites me to come and say a quick word. I guess, I don't know if everyone is in the room, but I would like to say thanks to Zorek, Heng, Maxime, Mohamed, and Bentley. So thanks a lot, people. You're great. So have a nice day. Have a very good symposium today and tomorrow. Thank you.
Thank you, Annie, for the continuous support also all the for SEMLA and Dado and also all the supporters. So our next speaker is coming from University of Waterloo to tell us about protecting user privacy at the age of AI. So Dr. Shi, yeah. So Dr. Shi is assistant professor at the University of Waterloo and Canada CFAR AI chair at the Victor Institute. Her research focuses on enhancing privacy and security within the realm of big data. Dr. Shi has several contributions leading conferences in database, privacy, and machine learning, such as Sigmod and VLDP and CCS and Triple AI. And she is also a co-author of a book under the title Differential Privacy for Database. So the floor is yours. Thank you for being here. And yeah.
Yeah, thanks very much for the introduction. Good morning, everyone. My name is Shi Hurd. I can call me Shi. I'm from University of Waterloo and a faculty member at the Vector Institute as well. My main research interest is on data privacy and security for data analysis and machine learning. It's my first time to be at a seminar. I'm really excited to share some of my limited experience in protecting user privacy in the age of AI today. And this is a very complex problem, so I couldn't solve it by myself, right? It's really for system security, software robustness, data access control, regulations, and policies. But today I want to focus on one aspect of it. How can we quantify and bound the information leakage of individuals while we want to make use of this sensitive data for developing useful AI tools? And feel free to stop me if you have any questions, or we can save the question to the end. So first of all, data privacy is not a new problem. If we can take example of the US censors, they play a very important role to allocate the number of representatives in the Congress and they build microdata for public use in many positive ways. Right? Probably they are one of the first largest organizations that collect personal data, and they have to look into the privacy issues very seriously, right? Because if they don't so, they have to face very severe penalties. Same for many business here. And so US censors have set a very strong precedent for us how to protect data privacy, but today's data landscape is very different. So not just the US censors, but even ourselves and many business companies are collecting our data. We have a lot of smart devices. Probably many of you are wearing some smartwatch, right? How about your phones? Your data get collected in many places, in cars, at our homes, even in public places, right? And here's a very interesting website, like it's an old website, but it's trying to raise up people's awareness about oversharing data. It basically say if you put a public post about Anna in a Starbucks places where she's in SEMLA today, right? Which means she's not at home, please wrong me. And there are more reactive examples. First of all, researchers were able to identify personal individuals from public release high-security data sets. And here is a heat map released by Strava, or a fitness application. And basically it shows the activity of the users all over the world, which is great, very cool. However, people can identify military locations, the location of military bases, and even the routines of personnel, right? This is very scary and dangerous. And something related to Canada, right? This is kind of 2022, I think. And the team Holland have defined that using apps to tracking people's movement every minute, even when you close your app. So if you improperly collecting or releasing user-sensitive information can be very dangerous to individuals, organizations, even national security. And given all the massive collection of sensitive data, it's really hard to predict what's going to be the next and how to prevent the next attack. Besides the challenge I mentioned just now, massive data collections, those data collections often take place in the background passively without informing the users. And it's also possible to aggregate data from all sources and to build a very detailed profile about each individual here, despite each resource may seem innocuous on its own. From the legal perspective, despite there are privacy and privacy regulations such as GDPR in Europe and in Canada, Bill C-27 have been recently developed, there's a lack of global standards, and it's really hard to enforce all these regulations in different places. And most importantly, it's really hard for them to keep up with the fast pace of AI technology development. There are many other challenges, such as algorithm bias, user awareness and control. But as a computer scientist engineers, something that I care a lot is about the challenges with privacy enhancing technologies or hacks. Right, the first challenge I want to mention is involving threats. Right, there are new technologies talking about deep neural network, and those can be used to identify sensitive information of users from their anonymized data. And there are also trade-offs on privacy. There's no free lunch. If you want to get privacy, something have to get lost, right? For example, the availability of services, the quality of the models I train, right? And last but not least, something that I guess many of us concerned, where we develop wonderful technologies, but there's a limited adoption of those technologies. So how can we deal with that? So today I'm going to focus on a very specific scenario to illustrate the challenges with hacks. So the scenario looks like this. The individuals have sensitive data, again collected by infrastructure, trusted or untrusted. But the first one folks here is the analyst, right? So we want the analyst to learn something rather than prevent them from accessing the data. We want them to learn something useful about the population. You can release some statistics about it. You can train a model for the data. So you still want to make use of the data for something good. But at the same time, we want to offer a strong privacy guarantee to the user in the data. For example, we like to allow the analysis to find out common patterns in transactions for building or fraud detection applications in financial industry. But we don't want the adversary analysis here to learn Bob made a transaction this morning, right? So this is the kind of problems we're trying to study here. How do we learn aggregate properties of data with a strong privacy guarantee for the individuals in the data? And I'm really glad we have a wonderful team of students and collaborators in the university to work on this problem. And many credits to them for some of the projects I'm going to mention later. So let's look at the first challenge involving threats, right? What is actually considered as a strong privacy, right, against these involving threats? So let's look at some of the traditional practices. The first thing probably comes to our mind is the identification, right? If you see, if you are trying to do a user study, the first thing is probably going to say that I'm going to remove the identifier in there when I'm collecting the data, right? However, a lot of the studies have already shown the identified data isn't really the identified. The core reason is that each person have a lot of detailed data points, and that basically form a fingerprints for you, right? And you can also get many of other sources of data to link this one and attack it. So this is for the identification, but what about anonymization, right? By suppressing some records or generate the records so we can analyze data and so on. But they also have a similar problems as well. How about just releasing statistics? Since I just want to do statistics, we release statistics about the population, right? But to make a long story short, there's a whole study about fundamental law information reconstruction. Basically, it says if you release too many statistics with high accuracy, you can basically reconstruct the entire table. Right, basically screw up the privacy. How about AI model? Something we care about, right? It does not have exactly a particular record in the model. It's basically vital parameters, right? Is it okay for us to release these AI models directly? I'll say it's probably no as well, right? There's a bunch of research work on how do we attack AI models, such as we can reconstruct the exact sample from the training data by using a model model. And you also can confidently tell whether a simple record has been used in the training processing model or not. And even by just sharing the optimal hyperparameter choice of a model that can leak some information about outliers in the data, right? It's very tricky, right? So if we release something without a formal price guarantee, it's really scary. And what actually guarantee we have? So it's very desired for us to provide some kind of formal privacy guarantee when we're trying to release data or ask queries over the data. So let's come to our first attempt, right? Here is the data analysis with the adversary, and we have individuals first by XI. It's an old picture. Sorry about that. XI in the data set. So what kind of privacy guarantee can I offer if the data analysis interact with the data? The first attempt can trace back to some statistical literature in 1977. The kind of idea is we say the interactions model by mechanism N is privacy preserving if the person cannot learn anything new about XI from the output of the mechanism. What do you think about the privacy definition here? Okay, since it's attempt one, probably it's not perfect, right? So what happens if she already posts a lot of information on her website, right? She probably couldn't blame for this mechanism to release some information about her. So the idea is, the keyword here is new, right? The person really shouldn't learn anything new about XI here. But how about if this study shows that, right? Majority of their PhD or working students spend their stipend on rent. And XI, whereas used to be her PhD students, so we learned that she spent most of her stipend on rent. Is this considered a privacy breach to XI? How do you think there's a privacy breach? No, right? Doesn't make sense. We learned something important about the population, and she just speak to be one of them, right? One of the population linked to this. Right, so this is not considered as privacy breach, despite you learn something new. So this privacy definition doesn't make sense in most of contexts. Right, so now let's try a second attempt. We're saying the mechanism N is indeed privacy preserving if the adversary cannot, or the adversary learns the same thing from this algorithm, whether xi is included in the computation process or not. Right, so we have two data sets here, D and D prime. D contains xi's data and D prime does not. And here's the output distribution from D and D prime respectively. And here the first three look at output, and he cannot tell whether it's generated from D or D prime, and hence he cannot tell whether xi's data has been used in generating the output, the reverse, right? So this kind of provides some indistinguishability to their individual data extraction. Okay. So this is actually a very nice idea and leads to the state-of-art privacy guarantee notion of differential privacy, which was proposed in 2006. The informal idea of this guarantee is that we say the output mechanism should not be significantly affected by adding or removing a row in the data set. So you can think about the row as an individual here. So whether your data has been included in the survey or not, the output distribution is going to be similar, right? So when you look at the output distribution, you cannot tell whether your data has been used there. So you can deny that my data has been used there. A more formal definition is here, just for any of you are interested. We say a mechanism N satisfies absolute differential privacy if for every output O and for every possible neighboring events D and D prime that very row, the probability to generate output O from D and D prime is bounded by interval epsilon. So among all these parameters, one thing I want you to remember is epsilon, right? Something interesting. It's a privacy parameter, or we call it privacy budget. It controls the degree to which D and D prime can be distinguished. The larger epsilon is, the looser the privacy guarantee is. The smaller it is, the stronger it will be. So if you think epsilon goes to 0, this ratio will become 1, right? So basically you cannot distinguish between D and D prime at all. But at the same time, you won't get any utility. Okay. The way for us to design the differentially private algorithms usually involve some randomness. So I'm going to talk about the privacy utility trade-off a bit later. And differential privacy is a very appealing idea, and US sensors have used it even back to 2008 to release people's living and working locations under differential privacy. And more recently, they applied differential privacy to their 2020 decennial release. And many of the big companies such as Google, right, Apple, Meta, name one of them, Microsoft, they always try to apply differential privacy in some of the applications, most likely internally. So I would say that differential privacy is a great opportunity for AI. Why so? If we look at the pipeline for AI, which is pretty similar to the first presentation, you can see that, right? We have some raw data being collected. You're going to clean the data, export the data, and from training data, you're going to do a training, you're going to tune the parameter of the model, and you're going to release the model and integrate it with production, and so on. Right, so this is a very complex process. And something about differential privacy is provide it is a obscurity. What does that mean? You don't have to hide any parameters of the algorithm, but everything is transparent. When you run process data, it's all transparent. So this is very important for transparency and explainability of trustworthy data. And the second property of differential privacy is provide a future proof. So it is that even if first we have some background knowledge, but have future background knowledge, right? They can still process the model that you see right now without affect the privacy guarantee offered. And the third really nice part of differential privacy is that we can use it to compose the privacy loss. So let's say I apply some absolute differential parent algorithm over the data cleaning step, and excuse me, and then apply absolute differential privacy over the training step, right? I can actually argue what is the overall privacy loss for the entire process. So that's something nice. But if you do something like k-normalization, diversity, you've heard those terms, but those techniques does not give you an overall market price loss. And there are many other properties of differential privacy. I'm not going to mention them all one by one. For example, differential privacy have a very direct relationship with the fairness guarantee of the algorithm. Those are related to the stability of the algorithm and so on. So differential privacy seems great solution has many advantages, right? but it has a pain. So this leads to the second challenge I'm going to talk about. Privacy utility trade-offs, right? Especially in information privacy, we usually inject some noise to the data or provide some randomized processes in the whole algorithm. So it's not really trivial how to design an algorithm that achieve the optimal privacy utility trade-off. So I'm going to start with one of the core phase in AI pipeline training, right? How do we do differential private training of a model? A very classic way to do it is use DPSGE, or differential private broadcast gradient descendant. It's very similar to the non-private version. So first of all, you sample some data points. Then you compute the average gradient of those points, and use the average gradient to update the parameters of the model, right? If you want to achieve differential privacy, you just need to do two additional steps. First of all, you need to click the gradient of each point to control the contribution to the final training model. And secondly, you need to add noise to the average gradients. And you repeat this process T iterations, and the overall privacy loss is going to be related to this T parameter. I use advanced composition techniques. And the overall privacy loss is going to be roughly proportional to the square root of T. T is the number of iterations we train. And besides DPSGE, there's many other optimizers we can use, and they often derive from the non-private literature. For example, DB momentum is derived from SGD momentum. These classes are belong to non-adaptive optimizer, and also have adaptive optimizer, which have few number of hyperparameters to train. And usually you can learn those hyperparameters adaptively in the training process. One example is Atom, and we have the DP versions of Atom called it DP Atom. So among all these choices of optimizers, which one do you think perform the best? Anyone have an idea? Right? I guess like we can experiment results, we won't be able to tell which ones should we really use, right? It's really not a trivial answer when you start this research. And another research work done in this field, people usually choose DP SGE or the non-adaptive DP optimizer as a baseline when they try to work on a new optimizer. The reason is that they provide a much better utility result if you fine-tune each one of them. But this is without the tuning cost of it, right? What happens if you consider the tuning cost of these optimizers? So this involves not just one single phase of training, but two phases, right? You have the tuning phase and the training phase. So one of the naive approach is that, okay, I have K configurations, so I'm basically going to run the DPSGE K times. And the overall privacy loss is going to be magnified by a square of K times here. So the final privacy loss depends on K. There's a more advanced way to do this to account the tuning cost, which is known as LT. Right? We're not going through all the details of the math here, but I just want to remember that this cost does not depend on the number of configurations in the tuning space. So which is better, right? So naturally, okay, we're going to choose which algorithm to use for tuning and which algorithm for training, right? We're going to pick the best of these two worlds. We're going to use LT for the tuning phase. We're going to use the non-adaptive DP optimizer for the training phase. But we don't necessarily get the best deal. We get stuck at a local optimum. One of the recent work studies this problem and find out the privacy cost of tuning plus training if you use DPSGE with LT right here. Or DP momentum plus LT get much larger privacy cost than if you take a suboptimal choice for each phase, DPLM plus MA. The intuitions behind is that the privacy overhead of LT tuning is much larger than if you simply combine DPLM with MA, which have a much smaller tuning space. Okay. And here's another example for you possibly to get started in local optimal. One of our recent work this year, we're trying to generate symptomatic data from database missing values. So that involves two phases in this whole entire pipeline, data cleaning and training, right? So a nice way to do is you're going to remove all the rows with blanking values in the data cleaning phase. And then you train a model to generate synthetic data and use the clean data. And this corresponds to the complete row approach I highlight here. But what happens if I choose to use our differentially private data cleaning methods here and then apply a differential private training process here? What is going to happen? Okay. And you can see the one highlighted by the pink rectangles, they get much worse error than even the baseline, right? So again, it's very easy for us to get stuck with local minimum if we look at things, if we don't understand the context very well. And we observe that we can probably just use one single model to impute the data or clean the data at the same time generate more data generation. And this is something that we design known as adaptive recourse approach. And this can give us much better error than the other prior approaches. So the story I want to end here is that it's possible to get much better results if you explore a broader solution space, right? But not everyone has the resources, time, and expertise to find their answer or explore the solution. So inspired by Epicor, one of the 2 million word leader in database, set this codes, right? The takeaway here is that we need to design useful systems that do not require specialized technical skills. So it is our interest to design end-to-end DB systems that can be accessible by a wider range of users. So here is the envisioning of a DB system for AI. And we have the sensitive data in the back of the firewall, right? And we have a really high-level language for general users to access this sensitive data, and the language can cover all the kind of operations that require for AI. And systems should also provide the up-to-date optimal differential private algorithm. So you don't have to explore what is the latest one. The system already update and provide support for that. And lastly, the system will automatically ensure approval privacy guarantee like differential privacy in the whole process. There are a number of database systems that already done this job, right? Like by Google, by Microsoft, Uber, and so on. But there are some limitations for them. The first one is they have limited DB query language and limited algorithms. I'm not too worried about this part because once they commercialize, we can always add or expand the query language and expand the algorithms. But there are 2 other fundamental problems I want to mention. The first one is they offer very inflexible privacy notions for complex data, right? Consider if anyone operating with graph neural network. So you have the rules that occur later, right? So you have more complex data than just a single table. And another limitation is that most of the system provide loose privacy control to ordinary nodes. I probably have some time to just explore some of these points later. So first of all these systems provide inflexible privacy notions. If you record the privacy definition of digital privacy I presented earlier, right, that's a very concept of one role, right? This one role corresponding to one individual, right? But how many roles do I really have? Imagine all the data that could possibly contain me, right? I could definitely have more than just one roles, and even more than one type of roles, right? So how can my system support all these different kind of notion of roles? In general, there are 2 levels of differential privacy guarantee people consider. One is row level or record level differential privacy. One is user level differential privacy. So I can use one of the example from the DP Postgres supported by Google here. So here's an example of one table that have all the fruits eaten by users, and you have another table containing all the users' information. So if I want to protect the differential privacy at a record level, basically the fruit eaten by the user, each event, right? I can simply write this query, select fruit count, basically count the number of fruits that each fruits have been eaten. It's pretty simple, and you can easily achieve this differential privacy easily. But if you want to ensure a much stronger privacy guarantee, like user level, basically you want to protect all the information about the fruits eaten by a particular user. And you have read this query here, right? And anyone grasp what SB does, right? Even me, I have to take some time to understand what SB do, right? So it's not, it requires a lot of privacy knowledge and even domain knowledge about this data set in order for you to write something correct for certain privacy guarantee. So about the same year when Google came out with this, we proposed our system called Privacy Hole. It allows you to define privacy at many different levels of resolutions. So the data owner who care about privacy, they can specify what privacy policy they want to have at their end. And the data analyst just need to write this query, right? And our system can automatically convert this query to query one, like a standard database system. But if the system knows that we want to support user level differential price, it will automatically change the query plan and find the best differential price algorithm to support us. Right, so we don't have to write such complex queries as the Postgres DP supported by Google. Okay. And this notion has also adopted by the US sensors for their decennial release, because they have to protect different levels of private entities in the database. The second interesting limitation for the existing DB system is that they only consider one analyst or one adversary, but inclusively consider all the analysts were collude, right? But we know that the application around the same data could have different privilege levels or different levels of critical levels. The practice we have seen so far, people do release a single copy of synthetic data with the same privacy level, right? This will result very loose privacy control to all analysts, despite some of them are for internal applications such as anomaly detection, or some of them for less trusty external researchers. There are also efforts to assign different privacy budgets to these analysts, but they still allow them to share privacy budget in order to improve accuracy. Right? Basically, they do not distinguish among these applications. But in our recent work, we consider this exclusive setup where we place different privacy bounds over this analyst. And even we allow collusion to happen, but we can design algorithms that achieve the lowest possible privacy loss by using correlated noise. Okay. For time's sake, I'm not going to do the details of everything, but the ideas, along with all these concepts, how do we design privacy, how do we want to get the best optimal algorithms, we built our several differential privacy system prototypes by the University of Waterloo. And we work very closely with some of our industry partners, such as RBC, how to generate end-to-end synthetic data that satisfy differential privacy for very complex transaction data. Also working with database companies such as Snowflake, how to integrate some of our differential privacy algorithms into their systems. And we also have systems that related to untrusted servers, where differential privacy alone cannot solve all problems. We have to leverage some of cryptographic techniques. Right? Know that the trade-off here is no longer just privacy and utility, but also performance have to play a very important role here. Okay. Time flies. I hope I can feel the lens of differential privacy. I see some challenges with tasks, but I really encourage a system-driven approach to support more useful differential privacy. And again, two more points I want to highlight that differential privacy does not solve everything, right? We need a lot of other aspects of technology to finally achieve different privacy preserving AI systems. And lastly, in all this process of adopting new technologies, I find that there's a great gap between researchers, technicians, regulators. I think some of your work is really valuable to address bridging the gaps here, and hopefully we can all together so that we can get a comprehensive privacy system. Thank you very much.
Thank you so much for this interesting talk. So we have a couple of minutes for questions.
Thank you for a great introduction to media. It's really interesting talk. So I'm just wondering, supposing that this study we're interested in misclassifying data, does the use of potential privacy help this adversary wants you to misclassify data? So it wants you to classify like an adversary of interest and another.
Yes, that's a very good question. So the question is that if what happens if the person who are interested toward some outliers or right, some probably not belong to the population, right? Where other different privacy rights which apply here. The answer is no, right? But there are variants of different privacy for such scenario. So I think for different privacy provide some idea or the framework how to prove something is private. But if you have a different idea about what is considered private, we can design a similar fashion, right? So we can shifting the whole arguments what using private, how to shape privacy issue, algorithmic design, right? If you can prove this algorithm satisfy this particular privacy guarantee you want, and then we're happy with this, right? So that's I hope that answers the question. Thanks.
Yes. Thank you for the presentation. I have two concern here is like what's the way try to achieve here we have this internal machinery and also what's the opposite here because at the end of the day you want to see how your model going into the reports. These are two things I want to go. First of all is the type of second is the
Okay, great. Sounds good. Yeah, I think the first question is how do we repatriate we go to, depending on who we want to become in the end. Right? If we want to become one of the persons who design those systems, I think we still have to go to all the literature of different privacy and how it achieve or how it can fit into the personal applications. But if we really do have a systems that supports certain kind of the exploration or training of machine learning model, hopefully we just need to be there. Be the end user who just learns on interfaces. That's the goal. Right? Hope that answers your first question. For the second question, the optimization part, right? It's a very good question. There are ranges of differential private algorithm from the simplest just adding noises. It's really arguing about their privacy guarantee or their privacy utility trade-off because it's just a simple noise distribution. But there are more complex algorithms. Like I mentioned just now, if you combine tuning space with training phase, you have the cleaning methods combined with the training phase, right? It's very hard to plot the privacy utility trade-off in that sense. So I think there is a need of tools for us to explain the trade-off, and then there are some efforts there, but more on the simple differential private algorithm. But I do think there's a how to explain the trade-off between privacy and utility for the more complex algorithms.
More questions? The concept.
Yeah, I mean.
Yeah, I think there's Mike there, so.
So I think you mentioned that your approach is applicable to federated learning, right? Federated learning models, right? Your approach. The privacy.
The privacy preserving machine learning model, yes.
So federated learning basically is designed for securing privacy. So in a server we send the parameter, not the real data, right? And like in federated learning frameworks, they apply different aggregation methods, fake, average, fake, average, and so it considers some problematic clients, like sometimes clients generate problematic data. It's kind of difficult for the aggregators to actually adjust the problematic client. So in your approach, do you consider that kind of problematic client who produces that data or why you cannot take data good parameter values.
Yeah, I try to understand the questions, but I guess we can take this offline, but a quick answer to this question is what I presented is very general framework, like a very simple setting. But there can be changes about the assumptions about infrastructure, whether they're trusted or not. We can make different assumptions about data, the quality of the data, make changes about assumptions of analysis. And each one may lead to different solutions, right? And there's a really vast amount of work, efforts made in that space. And I have to talk about this in offline.
Maybe last question.
Yes.
Yeah, thank you very much for the great presentation. So I believe virtual privacy is a great virtual privacy. The question I have is about very specific cases where you have small data sets with very precise and sensitive values. What happens when you use the virtual privacy and add noise? How does it affect the performance? And the second question I had was about the presence of adversaries that produce data. Are there techniques to kind of affect the training of the model that is trained on the virtually private data if you have adversaries within your data?
Yeah, thanks for the question. The first question is if the data set is small, right? A very good question. So there is a very interesting relationship between the axonal you need to achieve some accuracy with the size of the data. And my answer to this question is we don't know yet. And there are relaxed versions of different that probably give you better utility in that space. First of all, like when we're trying to work with our precision maxim, right? And we really have a very small set of data when we do. And I won't say like differential pricing is the right approach right now, but there come up with many other practices can limit their justification in each policy. The second question is, I think it's related to point-related attack. That's something that you mentioned, right? There are also a relationship between like cross-learning attack. And think that the virtual example is just one of the data points. If the outcome of the diversified algorithm is insensible to adding or removing that virtual example, then that kind of it serves as a defense to cross-learning attack, right? But there are also the skill of protection is something that researchers always want to explore, because you're not necessarily just insert one of virtual examples of more, right?
So I see there's many other questions. The good news, we have a break now, so we can really catch up.
Yeah.
I'm
happy to come offline.
with the break. And yeah, thank you so much. We have a small gift from that center.
Thank you so much.
Thank you. Thank you. So we have to be back at 11 for to continue like for the next 15 minutes.
No, I want to say thank you for the great talk. That was really interesting. What I was curious was, you know, you're bringing this idea of integrating differential privacy in query language, right, for data. And I'm curious, you know, I
about privacy and security, AI, and foundation model in general. We are researchers, so the goal of SEMLA is really to crack the hard problems around this topic. And we have a room half full with students. So we're interested in understanding what are the interesting research problems, research areas, challenges, perspective on which we should be focusing to drive this forward, right? Just to start the panel, since I have these esteemed researchers, you have the perspective from the industry working with government, which is dealing with very sensitive data and is trying to adopt machine learning. So I guess security and privacy are paramount. We have researchers researching in different techniques to secure the information that we're processing, secure the information in the models that we're building. So my plan is maybe each of you go around first, and then I will open to the public at the end of the panel. But what do you think are the biggest questions, the big problems in ensuring security and confidentiality in AI systems, in particular maybe foundation models these days that are heavily being used these days from your perspective? What are the problems you would like to see our students spending effort and time to crack to solve this problem, if you think it's actually solvable? So I have the mic. We want to go first?
I can go first.
Oh, okay.
Yeah. Very interesting question. I have two different items to answer your question with. One is something that I don't know if it's a research problem. And the second one, I think actually is a research problem. The first one being on top of mind for every single department today is around data residency. So that's the part that I think that is less of a research problem, more of a platform problem. So it's less of us doing something, more of Microsoft offering something properly with protected B coverage in Canada and things like that. So that's top of mind when I hear that a lot, like from different departments. The second one is around, and partly in the morning we talked about this. It's around the impact of what we're doing. Like that is a huge factor when it comes to these advanced models and technology. The impact of what we are doing, both on technology and and also on humans. So we are building models, we're building solutions, we are using their information. This is a cost. This is a cost in a sense that we are, yes, investing money, we are spending time, we are replacing humans. I mean, that's what we're doing to a good degree. The question becomes, how can I convince people that what I'm doing is actually to their benefit? So doing enough research on what it means and how it can have implications for people and for the workforce, for the current workforce, when it comes to use of their data and building solutions that make their life better and more efficient. Like that clarity is still missing. And I know that there are frameworks, lots of good frameworks, lots of processes, lots of metrics and things like that. But so far, I'm still struggling to find one single easy to understand, easy to grasp framework with a proper KPI and metric that I can say, for this solution, this is the risk, this is the problem, like numerically, not that the risk is high. That doesn't mean anything. Just proper KPI evaluating the problem, numerically evaluating the problem and saying, this is the journey forward. That is what's missing, the right framework, the right KPI, and the right path forward, which is not just a strategic. It means like something that means something. Like, for example, saying that we want to have a safer AI solutions. Sure, but what does that mean? We have so many of those terminology. We don't have much tactical action items or roadmaps when it comes to privacy and security.
Thank you.
Who should I pass it on?
Sure. Yeah, Miguel, maybe you want to jump on this. In your talk, you actually call for reusing some of the existing frameworks that have been in place in industry, especially in software engineering, safety, people working safety is critical system that we already have established practices and rules. How do you think that could be leveraged to actually tackle this problem?
That's actually like it's very interesting, and I'm learning from you, and us. Like I think these kind of systems, like I mean, as you mentioned that like FMEA or STPA could be also applied for understanding privacy concerns and security concerns, and actually kind of like transfer something to like I mean, like using FMEA, for example, having a numerical system to assess the type of risks, harms, hazards, or failures or system could face. And in addition to that, like if I want to think about another research path, which goes hands to hands with developing a system and tools for assessment, is to have stakeholders more involved. I mean, it's again like we need to have better tooling in order to be able to involve them, but also sometimes like some of the concerns that we have might be concerns that are not really like I mean, how should I say it? Like not the main concerns of privacy or security that some of the stakeholders have, or like we may actually not be able to cover all of them. So being able to like interactively discuss with the stakeholders and then integrate their knowledge also in the privacy or security system that we have, I think it's an interesting research directions that I would encourage if I had a student in this domain to continue.
Thank you very much. Maybe you want to jump on this?
Yeah, sure. I think I learned a lot from the very exciting presentations earlier today in the session. So I think there is a lot of open problems that researchers can work on. I think highlighted by many interesting use cases in the industry. For example, with large language models, they are often like new attack factors that were not analyzed before, and I think it's good to look into them. For example, it just crossed my mind after the earlier talk is that like synthesizing data is great, and then it can actually potentially remove certain risks, but could there be possibility maybe an attacker could actually infer certain patterns from the synthesized data? And if there is such possibility, we want to demonstrate and let people know that, hey, there is this problem, and then we design a solution that can maybe better synthesize data that protect against a certain problem. And I think with the large language model, it's also not just one model, often ecosystems of models, and some models are more well protected than another. And often there is this issue, are there any sensitive information that are stored in those models? Maybe we can mask out certain email addresses, but how email addresses are created using pieces of code. So basically, we're trying to concatenate certain strings together, and at the end, after the whole process, then we're gonna get maybe a particular string that may be sensitive, and then uncovering that may not be easy. So how can we do proper sanitization of data that is complex? And I think AI itself is applied in many different areas for various kinds of purposes. And in these different areas, there are specific needs. For example, I work on analyzing code, and source code looks pretty different from analyzing maybe natural language documents. And maybe there is need for more work that's specialized for source code. So just some of my 2 cents, the exciting direction in this problem.
Yeah, thank you. So hey, before you jump, I want to pick on the different collaboration thing. Now that we also have all this debate about regulations, right? One of the dimensions that we want to enforce in the system is transparency, right? Why differential privacy is somehow obfuscating the information so that we can't be recovered. There seems to be a tension in there. So how do you see that from your perspective? And what the opportunities you see there?
Yeah, sure. I definitely want to comment a bit more about transparency for AI and how it's related to differential privacy. In part of my slide, I say differential privacy definitely helps and support transparency of AI. But there's definitely a debate when the US Census released that 2020 decennial, and people say that, okay, differential privacy add noise to the data. How do you ensure the quality of the data? But to just step back, what US Census have done before also inject some noise in a different formats rather than differential privacy. I think the problem is really how do we present such a trade-off between privacy and utility to the public is very important. I think there is a number of follow-up work trying to show by using the previous approach made by US sensors and compare with a differential privacy version of algorithms, and then they have shown that differential privacy add less amount of noise to the data compared to previous approaches. So there's a need of like a study of how this trade-off between privacy and utility by different kind of algorithms. And this kind of transparency is very important, including like explainability and so on. I think the one point I want to add to synthetic data generation as well, since this is something that we have discussed just now, is there are amazing number of works have been done how to generate synthetic data. There's more like recent work using diffusion models as well, and we have tried that, including GAN framework and differential primal work, and it bring that much better utility as well. But what is the privacy risk, right? How do we evaluate the privacy of the synthetic data, and how do we even visualize the trade-off between those two? This is something that US census actually do a lot as well before they release that data. You can think about it, it's kind of a synthetic data, which presents the correlations of different attributes in data sets. But one takeaway I want to bring up is that it's very important to know what you want to learn from synthetic data. I know this sounds contradicting. Sometimes you are given a synthetic data because you have no idea what you want to learn, you just want to explore it. But the more you know about these, the goal, the utility goal, you're having more synthetic data, the better the synthetic data you can generate. That kind of align with what we have just now, or what we have mentioned just now.
Thank you very much. So any question, comment for the audience? Yes, please.
Thank you. Hi, I'm Scott from Beach University. Yeah, thanks very much for the great talks. I'm more of a software engineering guy, so my question is going to go more into software engineering direction. So I was worried. So one of the big challenges that we have is so when we're using LLMs to build systems, how can we have trustworthiness? How can we guarantee trustworthiness, right? So just to give a great example, so you were showing some of the systems that you've developed, and your tool number 2. I know you discussed about temperature and stuff, but some of the documents, for instance, that you're generating are pretty big, right?
Yeah.
So I don't know, an LLM could add a 0 to some number, and who knows, right? It's probably hard to catch those kind of problems too. So yeah, I would just like to ask you and the other great people there too, what have you done to try to ensure that your systems are trustworthy, such that you have security breaches and stuff like that? Thank you.
Yeah, maybe I can give a quick comments about that. I think their security and privacy are really achieved by layers of protections, right? So when we're including our LLM in the whole production pipeline, we probably want to do a bunch of testing, like that's part of more like related to SE problems. You want to do testing and ensure it is robust against all kind of examples, whatever cases that we can able to imagine. But probably machine learning or AI can brought into the space as well, can generate unseen examples that can help us to improve the testing, right? And I do think like differential privacy encryption techniques can play all around this space, depending how do we define diversity.
Please.
Yes, I think like it's very exciting problem to look at, like the trustworthiness. I guess you're referring to maybe a tool that can generate code given a particular prompt that maybe software engineer use, like GitHub Copilot, something like that.
Anything that uses an LLM, basically, right? Anything that can generate content.
Yes, yes. I think maybe I can comment on that particular setting. I think like in software engineering, we do have many other things. For example, we do have like checkers, we have static analysis tool, we have compilers. So recently, what we try to do is that 2 ways. One, can we actually combine the LLM to produce something and then check it against maybe static analysis tools to ensure that maybe vulnerabilities does not exist in the code that is being generated. Another direction that we tried recently also is on 2 things. One, maybe we can fine tune the model on those examples that are going to be bad. And then the model can be learning from it and then getting better over time. But one problem with that, it tends to be slow because we need to fine tune all the time. So recently we looked into ways so that we can hot fix the problem So in the sense that we provide a few examples and then do very quick tampering with the model so that the model can then avoid those bad examples. But again, none of these techniques come with guarantees. So if you're looking with guarantees, then that becoming a big problem because there is work done on like verifying AI, but usually that is done on like small neural networks with small like hundreds of neurons and things like that. When we're talking about large language model, they become very big problem that needs to be solved in a scalable way. So exciting research.
Thank you.
So I guess my question is, earlier this week, Apple announced this Apple AI, right? The main idea is that you cannot put a foundation model on the phone. So Apple was saying, well, we can send the data and we're gonna basically put it in a secure enclave, so don't worry about it. And we're gonna give you some kind of ability to observe the process, so you can check it. So with that in mind, the fact is that trusting the secure enclave means you're already believing that secure enclaves work, and if things go wrong, your privacy is gone, right? So the question, I guess, the bigger question for me is right now is, if we go all the way back when Gmail started, and everybody's like, oh my God, Google's, reading all your email, correct? And we've all moved on now, everybody's okay with that. Okay, so now my question is, so without Apple kind of going down this path, is really privacy dead, and people are actually preparing, the value you get from giving up your privacy is way more worth, what you're getting out of it. So that's one, and maybe the other thing was all your technologies, on the spot, you could have done it better than Google, so than Apple, right? So especially with differential privacy and that kind of stuff. And maybe for the government purpose, I guess with the one representatives, you feel the government will actually, be willing to have people use Apple devices, like Elon Musk is saying, why people use Apple devices and then just cut them off. Yeah, so discussion that point.
It's different the privacy. It's privacy standards evolving with the adoption of AI system. Is it that? Is it? What do you think of it? Who want to go first?
I can start with, because of the caveat on the Government of Canada question. The short answer, I think, this is just purely my opinion. I may be totally wrong. The short answer is no, a hard no. Just because of the resistance I see. And remember, with the government specifically, the problem is privacy, but the bigger problem is regulation. So it's less about the fact that, it is about the fact that whether my data is secure or not, but on top of that, it is about the fact that data is protected B. It's a top secret data. It cannot leave Canadian borders. Like, it's not something that people would get comfortable with unless we go back and change the regulation, which I think it's a century of work, like with the Government of Canada changing regulation when it comes to privacy, rightfully so.
So maybe jumping, not cutting. Do you think current regulations that we can adapt for the new reality of data-intensive and data-driven systems? If we want to reap the benefits of all these machine learning models, is GDPR really allowed?
That I don't have an answer for. I mean, that's a very deep question I don't have an answer for. Again, a very personal perspective. I would say a protected B data point should be protected B, if not protected A. And these are different levels of government security. So I think government is doing great job in terms of keeping sensitive data where they belong. That being said, I understand the restriction, and I don't know if it's about changing the regulation or somehow, like I said, convincing Microsoft, and that is happening now, of Canadian Government of Canada is a huge client for Microsoft. Come build a data center in Canada. Otherwise, we're not using you. Done. There is no other way around it. It's not about adaptability. It's about our data, our Canadian data, the need for that data to stay in the Canadian border. I think that there should be, I'm not sure. I mean, I know that I'm kind of contradicting what I'm saying in a way, but it's a very, very difficult question. I feel like government of Canada will not go through path of let's switch to Apple because they're going that path. That I have a feeling that that's the reality. Whether we need to change regulation or not, I don't know the answer. What is the path forward is adaptability of providers, technology providers, not us as a country or as a government. But that's just my perspective. I may be totally wrong.
Anyone want to jump?
So if I may add it as well, like I'm a perspective from Singapore, but by the way, like Apple a few months ago actually banned all its employees to use third-party AI services, and so it's like a little bit of contradiction there. In Singapore, I think the same in Canada, they often do not allow data from within the government to actually be sent to third-party services. So I think there is actually opportunities for researchers, including myself. So we have worked with the government of Singapore, how we can build maybe a large language model internally within the government. And then we not compete with like OpenAI because we don't have that much resources as they have, but we can have everything internal within the government. And another thing, I think people also start thinking there is actually a grant call in Singapore, big one from the government, on how we can train LLM in a federated learning way so that you don't need to share data. Is it even possible? So people are actually thinking maybe like besides on the regulation area, maybe also technology that enables that to happen. But hopefully exciting things are coming.
Maybe making a bit of push on this, because I don't know if you have been aware of the Instagram incidents, right? It was a few weeks ago, one of the leads, Instagram VP mentioned that actually pretty much everything you post on Instagram is used to train the models somehow, unless you explicitly decided that this was not. And then the whole argument is if we want to benefit from the capabilities that the model are bringing, we need to somehow feed them with the data, right? And we have this, like for example, I go back to GDPR, would give you the right to, let's say you want to opt in or out, and you want to own your data. So that very, very complex landscape for people trying to build this model for public rules, like not just, let's say in the government context, but in general. And my question about the adequacy of this regulation comes back. Like, do you think the privacy standard that we put up to what we expect from this technology? Are we not somehow contradicting ourselves by looking to leverage machine learning to generate capability and then putting restriction on the access of the data? It's a complex topic, but I really want you, maybe I want you as a privacy expert, what want to take on this?
Yeah, this is definitely a good question. Seems like two things are running the race: the trustworthy safety of AI and the innovation of AI, like which one go first. I would say this is I would see it's rather than a competitive kind of racing, but I would see something that can support or help each aspect to improve on. So by incorporating privacy preserving technology in the design of AI technologies, kind of slowed down, but it helps to rethink what we are doing in the past is correct or wrong. I would give an example rather than privacy, but for a bias perspective. Before we start to try to using AI to hire someone or doing recruitments, right? There are some bias hidden in the recruiting process. But then when we decide to build a machine learning model over the data we have used in the past, or the data we created in the past, then we realize there's a bias in the model. But then the bias of the model is coming from the data, which is something that we did probably not properly in the past. And then how we think, okay, are we doing the right thing or not? And we decide to push, okay, we probably want to build a model that is more fair, is more transparent, and so on. So this is really help us to think what we are doing in the past is right and how to do better. I think probably some of our own research work is just like pushing some of the limit of that may not really change in the world, I think. But we really help each other to think or try to make the world a bit better, help to solve the problem from probably a different perspective, right? For example, for different privacies, really helping us to think out of the box rather to allowing the data to be used versus not allowing the data to be used, but something that we can allow both to be possible analysis of data and the privacy of the users. Yeah, I hope that kind of answers the question.
Well, thank you. It's a complex question. It's out of the debate, I guess. I think we have any questions there. Yes.
First of all, thanks. Today I've learned a lot. And if we zoom out, one main point of today's gathering, I have a short sentence question, but I think I'm looking for a proper answer to this question. It's a short question, but I think it's quite controversial. Why should I trust you? I'm looking for the proper answer. So far, I haven't found anything. Maybe you can help me to find, because I'm working on that. I'm working on learning a schema. I'm trying to find out how we can convince people, especially the third generation, we can convince them that they can trust large language model or any generative AI. For example, my grandpa, my grandma, they cannot get used to this kind of technology, and they must be involved in this kind of life. Because it's happening. We are part of this. We need to build our generation, and we are talking about something that maybe some people cannot use it, cannot be convinced. So the question, how would be your answer? Why should I trust you, and how can I trust you?
Yeah.
Oh, I think you got it. Okay. Go for it. Yep.
I can give a quick answer for that. Like, how can you trust me? I will tell you I'm not trustworthy, right? I will ask a different question. We are responsible for our privacy and security, and everyone should play a role here.
Yeah.
I want to ask a question from, answer the question with another question. That you mentioned you. So what do you mean with that you? I don't want you to answer, but in general, so do we mean industries who are behind development of large language models? Do we mean developers? Do we mean the large language models themselves? And my personal opinion is that these systems could improve definitely in terms of privacy, trustworthiness, transparency, but I don't see a future that is you can guarantee that these systems are fully trustable, or you will get to a point that there is no issues with the system. It's basically, I think it's not a stochastic problem that it's actually stochastic problem. It's not something which you can just definitely say that you can address and solve all kind of issues that exist, because sometimes in research in this type of directions, we will see that there are problems that we didn't even think about them, that they could actually even be created in a couple of years. So yeah, I may trust the current system with sharing my questions with an LLM models, or use the systems. And I even as a researcher may not have a full picture of the extent of these technologies or where we are getting in a couple of years. So it's very important to ask these questions. The question that you ask, not just right now, but very often, and demand answers from government agencies, or basically anyone who is working on these systems, to assure for that stage that we are at, what are the preventive metrics and measurements and work that we can do, and what are the issues that currently exist. And I don't believe that we will get to a point that we can say for definitely there is no problem and you can trust us.
I can add something.
Yeah, sure.
So you asked, how can you trust us? I'm going to be very direct. First of all, thanks for the very direct question. You shouldn't. You simply shouldn't.
Thank you for the direct answer.
No, you shouldn't. Just because, if you're sitting here, and it was part of what I said earlier, right? this is not a real representation of the citizens, of the population. This is a community that is investigating the topic. So I think we are all collectively at the forefront of trying to make something work. And we all should ask those questions, and we should make it clear for ourselves. Unless it's not clear, we should not try to sell it to our grandpa. Like, it's impossible. And we're going to just like doubt it ourselves. So I think Nagar's point was bang on, in a sense that every day you're seeing something we had no idea it existed. And I think the comment we had earlier here on evolution of World Wide Web and Gmail and everything around that, we went through this journey many, many times over time. And people like us stood there, figured it out, and made it possible for our grandmas at the time to make it usable. And that's what we are doing today collectively as I think, just imagine the number of like thinking and time that like goes into our daily lives trying to figure this problem out. Like, this is impressive, and this is the purpose of this, trying to figure out how we can make it work. What she mentioned, and like Nagar, and also what we heard earlier, like on this panel, we have frameworks, we have path forward, we have metrics, we have like different things that we've tested. Are we sure? No, but we're trying to make it work. And there are two responses to that. Either you can say, I don't trust you, and I'm going to start, like, I'm going to continue using my Excel files and reading all the 300-page documents and whatever I'm doing the way I've been doing it for the past 30 years. Sure. Or you can say, okay, I'm going to be part of this smart ass community. I'm sorry for my language, but that's essentially the way that we should all collectively, as a bunch of researchers, deal with this situation, I think.
Thank you very much.
Yes, Nick, I agree with all the comments mentioned earlier. I'd also like to mention that I think there's a lot of unknowns.
Yeah.
So there are things that we do not know. So in terms of the regulation itself, I think maybe the regulator needs to try certain things, something bad happened, and then modify a few things until we really know what we don't know. And then we can design solutions for that. And I think in terms of like whether LLM can be trusted or not, I think it's also a question of what is trust. And I think, how can I trust a certain technology? What do I need? And that's something maybe personal. And maybe we can design maybe LLM with such features that can enable others to trust it by providing maybe evidence or rationales. But what exactly is the evidence? What exactly is the rationale? I think that's a big open problem. That's exciting.
Thank you. Yes, go ahead.
Gopi from SEMLA2024. Thanks for the great talks. I have questions that's twofold. One about privacy. The first one's about, I saw the presentation on the services built for government, right? And you were saying privacy is the key and it's very important. And I saw that you were using services like Claude and OpenAI. So I find when convincing people to use these third-party services, data governance and data privacy becomes the biggest factor. And I would like your take on how did you guys manage that? And for the privacy methods, a lot of these anonymized things in a group, right? And one of the key requirements of GDPR is that you're able to opt out. And how does privacy techniques work in tandem with this? And how can some of these privacy methods apply on top of third-party services? This is my privacy question. And for the other part, like all the safety and the privacy methods have a lot of overhead, right? Like, so it's really cool when you're building these things, but to actually use it at scale, there's a lot of gap, right? Like including building services for government or any big service. What are some of the big challenges that you guys have faced moving from this research prototype, like especially safety frameworks, right? The research prototype to productionization, and if you guys can comment on that. Thanks.
Want to go first?
I can start with a government-related question. So, valid question, but two sides to the story. One is, for example, the Doc Whisperer I showed you, and many other solutions, I must say, it's less concerning because the content that goes into the model is all publicly available. There are like all public policies that go into that model. And the challenge that the government is trying to solve is that these policies sometimes contradict each other. How can we identify those? That was the initial problem statement when we started working on that. So I think it's obvious that in that case, we're not too concerned about governance and privacy and those sorts of things. That being said, in reality, that's not the case all the time, right? We can have problem statements where we need sensitive information, as we've been talking all day today. On those specific use cases, what we're seeing is a lot of focus and investments on operating model, governance structure. What are the roles and responsibilities? Who should do what and things like that? And I know that they may sound a bit less technical. However, I find that in practice to be very useful and very impactful when it comes to use of these technologies for the government, because someone is at least sitting there saying that I'm not comfortable with what you're doing. Hold on a second. What is the regulation? What are you doing with my data and things like that? Because someone is tasked with that responsibility. So I find for the government specifically, defining the right ops model, right governance structure, right roles and responsibilities, and things around that being a huge, huge game changer over the past couple of months. I don't know.
I can talk about the next question that you mentioned about the scale. Scale was always a question on both the machine learning side as like how we can scale this model. It's like how we can solve these problems with like larger amount of data or larger models. And then also at the same time, like how we can test or like we can scale the testing and assessment for these systems. I would say that like we shouldn't actually like rush it to scale all this like assessment systems. There are a few considerations that I think would be a prerequisite for scaling. One of them is that there should be two types of assessment. One in the application downstream level, like the kind of context that that application or that program is developed in. Like, for example, you're using LLMs, you're using this like foundation models, like where do you use it at? Like which kinds of downstream tasks you want to use it for? That's like studying that context is very important, and to be able to also understand like what type of hazards, issues, harms, and failure cases can come up in the system. And then also on the model level, like the foundation model level, there are some research that basically take these kind of like questions on this like foundation model space, like embedding space, or like this manifold level, that if we can understand about some of these vulnerabilities even before delivering the system, even before actually releasing the models for a specific downstream task. These are the two approaches that exist, but then again, like it should be very carefully designed, and all the stakeholders should be involved. There should be so much information collected, like it shouldn't be like rushed into a very, very automated end-to-end system. Like exactly opposite of like the way that we are developing foundation models. So for the testing, we should actually like go with more caution and more care.
Yeah, I can talk about the privacy part. I think the questions are asking the relationship between like differential privacy and some of the requirements from the regulation. For example, GDPR, there's like the right to be opt-out, right? Yeah, I think there's a really active line of research work trying to mapping the regulatory terms with mathematical definitions. So there's more than just one privacy definition had defined that space, and differential privacy is definitely one of the options that can relate to the choice of opt-out. It's basically saying that whether your data is used there or not does not affect the final analysis, right? But again, how to explain the intuitions to general users, to policymakers, itself is a very interesting question. And there's a lot of user study, how do we explain differential privacy to the public, and how we can design algorithms that make it more transparent. That's a lot of like active ongoing research. I don't have an exact answer for you, but I think it's a very active and very important aspect. How to bridging the mathematical privacy notion framework with the law requirements.
Okay, so we'll take one more question. If that's okay.
I cannot hear you.
You hear me now?
Yeah, a little bit closer.
And you don't want to solution, because my question is related to transparency of privacy, because from the perspective of users, different users would have different preferences on how much privacy they want to give up. So imagine 5 years, we all have AI agent system. That's the more privacy we give up, the better this AI serve us, right? So I feel that different users really have different preferences. But currently, I think most users will like the back most users have most choices and understand the trade-off how much they can give up, how much benefits they can get. So do you think in the future we should give users more choices and how can we improve transparency to that effect?
Sorry, my background is not on privacy, but like I want to like take this question, like the beginning part of this, that we should actually give this knowledge to the users. Even, I mean, like you see so many of this, like you want to use something and there is like this like 20 pages of rights that you have, or like things that you can actually give up, and I have no idea what they mean, like from legal terms. So if we really want to give this control back to users, I think we should also have a very simple way of like educating them on the type of rights that they can have potentially with the systems and what they will be obtaining in a way that is like more understandable than like 20 pages documents of like very difficult like legal text.
So I think that's a very interesting question. So I will not talk in the context of AI, but recently my visiting student and I, a couple of collaborators, think about Android app. So when Android app, sometimes the terms and conditions, for me, usually I just scroll to the end and then accept, because I don't want to read 20 pages of document. So what we were doing actually, will be presenting soon in CCS, is that we try to find paragraphs in that long document and hide back with certain widgets in the Android app, so that we will know that, hey, if you let us this information about you, then we can make we can offer you this particular service. So we want to make that linkage more apparent. So I think that can be done for Android app, because there's a lot of widgets, and these widgets do a certain thing, and that can be associated with certain kinds of data that has a certain policy in the privacy policy. However, for AI, it will be pretty different, because sometimes like I want to share my travel log in the last 1 year. So what can I get out of it? So sometimes it's very difficult, depending on the target AI that I'm using. Does it mean I get like 3% more accuracy, or 4% or 5%? I think it requires a lot of thinking in terms of like how can we communicate the utility versus the privacy that I may have lost to this AI system.
Okay, one more, and I think we'll go for lunch. We can continue this discussion over lunch.
My question is for Elmas, and since she's working in with the most resilient people,
Well put.
so in software engineering practices, we all learned that so we have to involve users, and so that they would like support like software engineering process. My question is that as we are going through towards this more threatening automated systems and AI work, so what you've learned in this journey from the human perspective and software engineering perspective, that how you involve these users, maybe having a role for them or something else.
So If I understood correctly, the question is about how we overcome resilience. So it exists, and we usually don't. Okay, let me let me reframe my thoughts. So it is all about the sponsorship, especially when it comes to government. So there are a couple of role models, very known role models at the government, that they are the force behind many of the initiatives I talked about today. The people reporting to them mostly are the resilient community. The good thing is that they are reporting to them, so they don't have the authority to say no. That being said, it's not sustainable, because at some point this person will move somewhere else, and I'll use that sponsorship for building a new solution and building a new tool. So what we have seen over time, like the first, second, third maybe solution, was more about people not liking us, sponsor being happy with what's happening, and then we were kind of like pushing things to their daily lives. That being said, we figured that it's not going to be sustainable. People will kind of like just make it worse and worse over time, because at the end of the day, I'm building a solution for a case worker. And if the case worker doesn't use it properly, I'm in trouble. So what happened was that we started hosting different kind of, and Nagar touched on this as well, on like training the user, literacy for the user, making sure that the user understand what it is that they're getting, and what was mentioned here about the trade-off between what you're losing versus what you're getting, and trying to explain that to them, to the user, that we're not replacing you. You will have your job. We actually have a more important and more exciting job for you. So making sure that the user understands what it means for them to have a new platform, to have a new solution readily available to them, I think was a success factor. Do I think that we are done with that and people are all open to the change? Definitely not. Yeah, we still have life there. Yeah.
Thank you very much. We get to a close. So to close the panel, I just want to give our panelists the opportunity to put some closing argument going on. One topic that I wanted also to touch, but we don't have time, it's also the fact that this high capacity model, we've been discussing our privacy and confidentiality stuff, not much on security and the security risk that this high capability model are contributing in a sense to also increase the landscape of potential vulnerability attacks, because people can leverage them to launch more sophisticated security issue and so on. So that's another perspective to the problem. Maybe to close the panel, I just want to pick your brain on this. What do you think this trajectory on which we are on machine learning and more learning, high capability, versus security, privacy constraints, how do you see these two going forward, in looking at both ways? And what should we be really watching out of here on the headline? Maybe 1 minute, everyone. Just share your perspective. Maybe we'll start in reverse. Okay.
Security, yes, there's a term like AI-driven security. So you can use AI for security, and AI can hurt security as well. Again, as a researcher, I was trying to figure out both ways. Like we often act as an attacker and try to attack the systems with new technologies. But it's great that we have a lot of wonderful, smart people here and try to work out the problems and try to catch up as fast as the real bad attackers is doing. So I think it's really a collective efforts from every field. And that's something I noticed, for example, when working on artificial privacy, but it's a topic everywhere, like in database system, in machine learning, I definitely believe there's a lot of several works on SE as well, systems. So to achieve even such a simple ideas, artificial privacy requires such efforts in everywhere. No mention about the real comprehensive privacy ecosystems. So I think it really requires a collective efforts from everywhere. And myself is really stretched my mind to be everywhere and try to learn from all the communities, and hopefully can make some efforts in this direction.
Thank you.
So I think there will be an arms race. So it's large models can be used for good things and also used for bad things. So recently I went to this AI for Science workshop in Singapore, and then there's one person saying, can this large language model be used for penetration tests, breaking into systems? Yeah, and I told them that yes, a few weeks ago there's a company that has already got investment to build this, so it will coming soon. So I think there's an arms race. We are trying to protect the system. We also, some people also trying to break the systems. So, but it's an exciting time. But I think there's a role of government and also regulation. There's a lot of unknowns, but if regulations can be put there, maybe guardrails can be put there, we can prevent this bad things from happening, or at least we can keep them in control. Another thing is that as AI is getting more and more controlling many different things that we do. For example, human working with AI to write code, AI is scanning for vulnerabilities, AI is doing many other things. So the AI itself is actually is the weak points. So human is the weak points. In the future, if AI is going to replace humans to some extent or another, then AI become a weak point, and we need to put more emphasis on securing them. Otherwise, then in the future, if we attack those AI parts, then we can break a lot of things. I think there's now a lot of emphasis done on like data poisoning and other things for which AI can be attacked and do something that are really bad. So I think we can either paint it as like with a group picture, things will be very bad, or with the positive pictures, things is uncertain, but with a lot of uncertainty, there are a lot of opportunities, and we go together and we can solve this problem for a better future. Great, good points.
I'll go very short. I think that the key is acknowledgement. And I think events like this and many other events that are happening and all the research that is going into this is kind of like showing how these two topics are going hand in hand of like AI and privacy. And the fact is that we don't know the right answer yet. But at the same time, I don't think one is stopping another. It's just a matter of finding that right balance that works for different people and different sectors and just going with that. I think it is important that we all acknowledge that there is a privacy concern, there is a problem. We are all collectively working on it, and we're going to figure it out like any other topic that we have figured it out.
Thank you very much. Yes.
I'm a little bit pessimistic about
We need a controversy anyway.
yeah, like about basically having an AI system that would maintain itself and like be able to actually protect for privacy like all the time. So I think like even like if the systems are so advanced, like we should always like, I mean, this is kind of like my ignorance part that like I think that like humans should be always like involved. And when I'm saying humans, I'm talking about like people with expertise in various fields which are very relevant, and also stakeholders who are impacted. So we shouldn't like leave the system completely to get to a point that these systems would actually get like attacked. There should be like so many interventions in between, like so many, like, I mean, I'm sure that like there would be interventions, but there should, like, it's like the goal shouldn't be like at some point we will get to a point that we won't have like any, like we would have an AI system that's strong enough that could preserve security, because like both systems are AI systems, and definitely like different agents could actually address, like eventually like understand and overcome the type of security protections that have. So yeah, I think, I mean, I'm not sure even like human involvement would be sufficient in this type of scenarios, but
human AI collaboration.
Human AI collaborations, yeah, I like, yeah, human AI collaborations, and the human part should be like stakeholders from very various backgrounds and experts.
Okay. Thank you very much. I think this is. Thank you very much to our panelists. We have been in our lunch, but I think we'll make it. The instruction for the lunch, they have been to follow our volunteers in the dark.
Nice to meet you. I have been in Singapore for
خیلی خوشم دارم. آره
I'd say
شما مونترال
secondary school and then high school and then college. I was in US. Oh wow. Which year?
Graduated 2008.
I think I joined AUS in 2008. Yes. Yeah, and then 4 years.
I attended also PhD.
Thank you so much.
Thank you for the good discussion.
I used to get with
Thank you very much for the good discussion. Actually, I will look more deeper in your work. I feel like you do a lot of cool stuff. As usual.
There's some overlap.
Yeah.
I did my bachelor there. Yes. Yes. I spent a lot of time in Singapore when I was a student.
You're from the same alma mater.
Yeah. Oh, you see. The distance just got shorter. Thanks for stepping in last minute.
The full expert.
Well, I mean, same for me.
But I have to take care and participate a lot of things.
It's a good discussion.
co-chair for this SEMLA. Okay, I'm really happy to see you all here. I hope you had an amazing morning. And we have a packed afternoon for you as well. So we are going to have 3 amazing talks and the panel to conclude the sessions with some breaks in between. So our first speakers doesn't need any introduction. I think he's actually like why that name precedes him, but I should follow the protocol. So he's an HCM IEEE and NSERC SDC fellow, a laureate of the prestigious Mustafa Prize for funding the AI segment for software engineering field, and is associated with Software Repository Conference. And he's also a distinguished educator of IEEE TSCE and the influential educator of ACM 6 and he holds the Canada Research Chair and also NSERC and BlackBerry Software Engineering Chair at Queen's University. So without further ado, I will pass it to Ahmed to start.
So, yeah, so today I'm going to be talking about work that we've been working on for the last maybe 2.5 years. So this is probably one of the biggest projects I've worked on. So there's a lot of people involved. So there's a lot of names here. But actually, a few of these people are in the audience as well today. So if you have any questions about the work, reach out to them as well or to me. And you can see there's a code here. So this is based on a paper that we put on archive. It's like 30+ pages that kind of talks about the future we imagine of how software will look like. The biggest difference from a lot of the work you might have seen before is we believe that software itself is going to totally change. So I think a lot of you have seen a lot of work where people are generating source code, right? Well, imagine a time or a world where there's actually no source code anymore. And I'm going to walk you through exactly what I mean by that by some examples. So classical kind of rain sensing windshield wipers. If you buy a car, a lot of cars come with rain, a sensor that if it's raining, the windshield wiper will actually operate by itself. So there's 2 versions of this. There's what we call the codeware version. So you have some kind of optical or infrared or acoustic sensors, but you have a lot of source code. And the developer writes code that code is trying to detect where there's actually rain, and then the sensor will actually activate. Well, now look at a different perspective of this, which is an AI-ware. So now, instead, we have taken thousands of pictures of windshield that had rain on them and thousands of pictures of windshield that didn't have rain on them. And now we have a model, and every 1 millisecond, there's a camera on the sensor on your windshield that's taking a picture. And based on that picture, then it decides where it's rain. And then if it's rain, then we'll activate the windshield sensor, the windshield wiper, sorry. Okay. So now there's a bug. Let's say, for example, in that case, you're driving in the sun, you didn't have a picture of the sun hitting your windshield. Therefore, the sensor gets confused, thinks it's raining. Then it activates the windshield wiper. How do you fix that? Well, it's totally different than the classical way, because all you need to do is you take a picture and you say, there's no rain here. And therefore, you fix the bug, okay? Lots of code, almost no code at all in the other one, right? So really, we're moving for this world where is this codeware versus AI-ware. So the idea here is, if this is kind of the most complex software system we can ever write in the world, and if we don't have to write, we actually have to find that program as developers. We have to write that program in a codeware. We're limited, unfortunately, by how smart the human is, okay? Instead, now, when we come to AI-ware, we don't actually write the code. We define the source space for that code. We give the data, and then we have the AI model, the AI infrastructure, the model learning, find that piece of code, that software, okay? So that's a very different world that we're thinking of, okay? So now what we think here is we're moving with this idea of software experts to software makers. And now what happened is, so we have this big shift, which is foundational models. So we think of foundational models as we basically call the calculator moment of software engineering. Okay. So when calculators were created, the good news is we didn't kill all the math professors. Okay. And when Excel was created, we didn't get rid of accountants. Instead, math professors were doing way more fun stuff, and accountants were only brought in for the complex stuff. Okay, so the same thing will happen now moving forward in this new world. Okay, so now we're moving from millions of software developers to billions of software makers, and now we have this idea of the developers that are happy, that are not having to deal with all the weird, parameters and what does the if statement look like, and should this be a null point, should this be null, or should be 0, this be 1, all of that. Okay. And foundational models have enabling that to be much more easy and possible. So really today, we have moved from generations of software, right? So we've moved from what we call codeware. So this is where we talk about that rain shield wiper kind of software system, lots of code, okay? To now this newerware, which is kind of more deep learning, okay? To now promptware, so you're prompting a foundational model system, to agentware, and then beyond that, what we call is mindware, okay? So mindware, the difference is actually not based on foundational models. So these are called FMwares, and these are called AIwares. Okay, and actually I want to emphasize something. So the example that I gave of the windshield wiper, that is real. Actually, the Tesla cars use that technology, okay? So it's not like I'm just talking magical stuff, okay? So now we have actually been seeing we have moved from this, if you think of software as kind of evolving from end user programming, okay, to kind of enterprise programming, to systems programming. We're now seeing more and more of the ability to kind of write your own personal avatar, what I would call essay programming, artistic programming. We're seeing that happen. Okay. Here we have the end user kind of in the loop. Okay. Now in here we come to these enterprise systems. Instead, what we're seeing here is the experts are on the loop, right? And there's limited user in the loop interaction. And we're already seeing very nice examples coming from Microsoft or Office 360 or for the Microsoft Flash Fill technologies, for example. Okay, and we have already been seeing some early prototypes of this operating systems or databases fully replaced with a foundational model. Again, the main point here I want to emphasize is we are not here to generate code because code is gone. Okay, now there will still, the key thing I want to emphasize is it doesn't mean, maybe I'm going to go back to this slide. It's not like once we move to this, we forgot everything else, okay? So software systems is gonna be a combination of agentware, promptware, codeware, all working together. And that's where the complexity comes in. So this multi-generational aspect. So we've been working on creating, kind of rethinking the whole FMware lifecycle. So instead of software lifecycle, the FMware lifecycle. And think, okay, what are the phases we know about? So, we are requirement engineering. So the good news, if you're requirement engineering, you're still in business. Okay. Now, beyond that, instead of thinking of architecture or this idea of cognitive architectures instead. Okay. And then you go at the design, implementation, and testing, and things about interaction designs, picking the right model. So we are the idea that there won't be only one model, but it's going to be multiple models being used in a system. So it's not only GPT-4. But instead you have GPT-4, GPT-3, llamas, even your own small models, all of that, like the fine models. Then the whole cognitive architecture design, prompting, agentware, and then in addition to that, you still have your classical libraries, classical tools, and then actually the testing and the serving and all that, the quality assurance in there. So with that kind of life cycle, and based on experience from developing a few of these and kind of working with some of these large systems, we went in and tried to understand, okay, how hard it is to actually move this software systems from nice, I would call them Twitter demos, okay, to actually products. And the bad news is it's very, very easy to get a Twitter demo. It's freaking crazy hard to make them production-wise. And the problem today, a lot of the business leaders say, oh, in 2 weeks, you can do this. Well, if I give you another 4 weeks, we can ship. That shipping part is very hard, right? And, we have seen this already. So, for example, Andrea Karpathy was talking, it's easy to demo a car self-driving around the block, but making it into a product takes a decade. Wow. We don't want things to take a decade, okay? Not a lot of people have all the money that Tesla would have, okay? Now, this is not just talking about, car driving, but here is, a blog from LinkedIn. So they just integrated some FMware recently in their backends. And what they were saying, it was very discouraging the rate at which they were able to improve the quality. So getting up to 80% was very smooth and very quick, but now every 1% in improvement of quality was extremely hard, right? GitHub and Microsoft. So this was a survey that was done by Chris Harlan's team at Microsoft, where they talked to people that really built all the recent GPTs, all the co-pilots from Microsoft. And one of the things they said is traditionally in regression testing, you just run the regressions, but now every time you run the regression test, there's real dollar amounts being factored in, okay? So how do you change testing? And then now I was just talking to people at Red Hat, and one of the things they were saying, what's happening today is already the industry was barely able to get their head around, what we call neuroware. Now foundational models even take it much more complex, and the capability of the workforce and the cost of that type of workforce is even much harder. So, what are the challenges when you productize this FMware? So there's kind of limitations of foundational models themselves. So their ability to deal with complex tasks, hallucination, closed loop. So they can't really kind of change the outside world. And then engineering pain points. So low productivity, high risks, and high costs. So what we did is we actually created 10 challenges. So I don't have time to go for all of these 10 challenges. I'm going to kind of go for some of them. And then the moderator is going to give me a sign, and I'm going to skip through the rest. Okay? Good. So managing alignment data. So remember, we have actually gone around from managing source code to managing data, okay? Because data is really how you program now, okay? So we have here, there's all these new types of data, right? And it's very expensive to curate that type of data, and it's very slow processes in place, right? Data leakages. So today, when you talk about, so human eval today is inside Copilot, inside GPT. If you actually talk to ChatGPT, it has almost all of human eval in it, right? Okay, then the other thing is, how much data do you need? A very nice work that's coming from Microsoft is the Phi models, where they have shown with very little data, very small model, you can actually outperform, ChatGPT, like GPTs for specific cases. Okay. Now, state of the practices. So today, there is some work done on kind of active learning and weak and self supervision. So work by Snorkel, for example, or actually is very promising there. And then one of the concerns that we're seeing around is people are using GPT-4 to train other models. Well, the problem today is the model is training another model, then you can have the model could collapse. Because if enough training happens, all this artificial data, you get to a stage where there's no more signal anymore in that noise. Okay. So, so some of the work we think is interesting is this idea of actually how to intervene, and actually automate the labeling, kind of human in the loop kind of working in there, okay? And then what exactly does it mean open source now? So what is open source in that world, right? Because now you have, you don't need to program it, but you can actually contribute much nicely into the open source initiative, right? And what does licensing mean in that context? And, we don't talk about it in the data aspect, but even now when you have today when you download a library from the internet and it has license X, and then you try to use it later, it's still the same library. You download an agent from the internet, but 3 weeks later, that agent has evolved. What is the license of that agent today? How it is evolved? Okay. Now, the big thing, I guess, right now is this idea of prompt and prompt engineering. So there's a lot of prompts here. So the idea is prompts are too low level and fragile. So very small changes, there's a lot of trial and error in there. Prompts don't transfer, even for the same model, from GPT 3.5 to GPT-4, from GPT 3.5 to different versions of 3.5, the prompts don't transfer, and you have a lot of difference in the quality of your software system. Okay, it's very hard to reproduce the results. So now, some of the state of practice today. So today, for example, it's very hard to debug. So that, well, we have some recent work. I think this paper is on archive already. Is it on archive? I'm not sure. Okay, but there's a paper base that we're working on is actually creating a debugger for prompting. Because right now it's like it works or it doesn't work. There's nothing in the middle, right? So you want to understand why it's not working. Am I getting warm? Am I getting cold, right?
Where in the old days when we have source code, you can actually say, okay, yeah, code dumped right here, okay? So how do you deal with that? Okay, how do you optimize prompts? Is another challenge. In particular, again, remember, the best way I would describe it is humans are not designed to write prompts the same way we're not designed to write assembly code. And the way we see it is prompting is actually the same level of assembly. And I'm going to show you an example to really kind of nail the message home, okay? So, there's higher level, we need to go that beyond kind of how do you actually do higher level type of prompting? Okay, reproducible prompting is an interesting direction. And really, I think we don't call it prompt engineering, we actually call it prompt hacking. And we need to go to that intent programming. And I'm going to give you a very simple example. So this is work, so this is a paper called How I Learned to Start Worrying About Prompt Formatting. So you can see here, so this is one prompt, so message, colon text, answer colon text. Just removing this, I increase the performance, the task accuracy, okay? Now I have it all caps, I have it lowercase, okay? I just put it on the same line. So I'm hoping, I've always been trying to convince people about how crazy prompting is, but I think this tells you how fragile we're working this, okay? And then now you finally get this under control, then there's a new GPT out, and you have to re-optimize. Okay, so it's extremely inefficient, it's extremely fragile, and you have no idea why this is not working. Okay, so some of the technologies, for example, we have developed is to tell you, you know what? Somehow the foundational model is really fixated on this column. And we can actually flag to you that this is really, for whatever reason, the foundational model is doing this, then you can actually know how to improve at least your prompt. And we're moving beyond that. Really, what I would say is humans should not prompt. Nobody should be writing prompts. Okay, in the next, I think, middle of next year, prompting will be, almost gone, or at least, it's the same. So now, will it be totally gone? Well, it's the same thing as assembly code. There's always somebody writing assembly code because they think they can get the last piece of juice from the CPU. Probably will happen still here. Okay. Multi-generational software. So this is kind of emphasizing the key point I was saying, which is we will have different types of software, codeware, neuroware, promptware, agentware, all working together. Okay. So how do you integrate them together? Okay. How do you actually, changes in the legacy software system impact the downstream FMware you're developing? So we're seeing two directions here. One is plugins. The other one is how do you package software into tools, and tools are used by agents. Both of these today, as a software developer, you have very little advice on how to do that. How do you actually package a library that an agent can use, right? What does it mean to have, instead of an app store or an open source library that actually has been documented in a way, instead of a human using it, an agent using it. So, the key point out of all of this is, well, people kind of sell you that this is a whole new world. It's not a new world. It's not greenfield projects. There's a lot of legacy. The legacy comes from your source code, comes from your data, and how you bring them together. So how you make them reusable. So not only the legacy software, but actually the data. And then control. Today, foundational models, I cannot lie to you, they have a lot of craziness around, right? So they can hallucinate. How do you actually make sure you can still produce reliable, trustworthy software while controlling it? And it's the same way how you make sure that your new intern, undergrad intern, is actually doing good stuff and not going off the rails, okay? So you put guards, you put more senior mentors to do that. How now you design software with that in mind, right? So, how do you have this robust controllability? Now, today we are seeing some restrictive approaches, what's called standard operating procedures, as ones, for cognitive architectures, where you kind of describe 80% of the software, you put the rules, and then you give the foundational model some flexibility to do explorations. Okay. But the problem with that is you're basically limiting how far the foundational model can serve. So if you remember, I showed that picture was this big circle, and then if you define the search space and you give the AI the freedom, there's a good chance they will actually find better solutions than we can think of. So the more control, then we kind of go back to codeware. So we want to give them more flexibility, but at the same time, enable them to do more, make sure that they're safe and trustworthy. So yeah, so this idea, how do you actually do fine-grained boundaries? You know, so how do you do permission systems, for example? Think of the Android permission model done for agents. So you can download agents, you give them access to some things, you don't give them access to other things, and then you can collaborate on your behalf. Okay, and this autonomy versus control, you know, restrictions is another big challenge we need to deal with. Okay. So compliance and regulations, yeah. So human oversight is a big thing, especially with the government regulations in place. You know, and how do you, you know, make sure that if you're using third-party foundational models, that data that's being moved, actually all the regulations and all the GDPR and all the rules are actually being applied to that. Okay, and then one of the biggest things I guess that's happening around open source, what exactly is the definition of an open source model? Because now we have open source weights, open source training, data, and then actually a truly open source model, and the variance is quite big. And then what are the implications of the data as well? You get your training, okay? So today there is very little automation in here. A lot of it is kind of done in a manual process, kind of there's a lot of lawyers involved. We believe a lot of that can be automated, okay? And then the differences between a data license and an actually software license is becoming a big focus here. And what even makes it more complicated is different countries have very different, you know, expectations of what exactly is the license of the data and what it means if I derive something from a piece of data. What license do I keep? Okay, so what we've been working on was the Linux Foundation is actually creating what we call, so instead of like the software bomb, so yeah, so instead of the software bomb, earlier this year, we actually worked, so Gopi here is in the room, but you know, we worked on creating the AI bomb. But now that's just for AI software, like neural software, but now we need to actually figure out how to do that bomb for actually foundational model type of software. You know, how to actually do verification and testing with that in mind. Okay, so, okay. So collaboration support, right? So remember I said there's no code or there's little code. Okay. The question right now, and actually that's a question that even I think people who still believe that codeware would exist is what do you version? Do you version the prompt? Do you version the output of the prompt? Do you version the final outcome? What do you version? Okay, so that's if you have code. If you don't have code and you have agents that are talking to each other, there's actually no code in it. Okay, so a couple of things happen. If something goes wrong, you need to debug. It's actually like you can't put breakpoints. Okay, you can't actually go back and force the foundation, like the agents to go back to the same code path. So you found that you fix a bug, getting it to go back to the same code path is its own challenge by itself. Okay, so these are some of the problems that people are really kind of trying to make these real software systems and ship them out, right? Okay, so basically there's a lot of different standardizations, a lot of different formats today. For example, when you think of these vector databases, you know, there's a lot of work today on trying to actually standardize these and rankers. All this is just, it's just a Wild West right now today. And the reality is, all I can say is we are kind of at the punch card era of developing FMware. You know, grown-ups don't develop software like this. We have kind of evolved over the years. We went from like, you know, punch cards to like VI, sorry about that. Then we kind of evolved to Emacs. Okay, then we had Eclipse. Then we have actually, you know, real platforms. There's a big gap happening here, right? So, you know, okay, so, you know, what kind of assets you need to, you know, archive is the challenges here. You know, there's no established standards for even hubs. Okay, so granular version and so on. So I'm gonna just fast track to the end, okay? So semantics observability is another challenge, but we're not gonna talk about that. Okay. Okay, good. Okay, so what we have done is this. So all these challenges came from two things. We actually 2 years ago we decided that what is the Eclipse for that new world? Okay, what do we need to build that will make the life of developers easy when they're building the software systems? Okay, as I said, as simple as how do you actually edit a prompt? How do you debug a prompt? Okay, whether prompting even makes sense altogether. Okay, does it even make sense to produce source code at the end? Instead, you should actually produce something that goes on a new runtime. So this is what we actually went through, and we actually created a new runtime. And that runtime came from actually a realization of a need, because we have limited access to, GPUs and NPUs. So we needed to create something where we can run, 30 people developing these type of apps, and you only have like 2 GPUs. Okay, how do you do that? So that was kind of what there. Okay, then the framework that actually goes on top. Then actually, how do you manage the assets? How you do the prompting? How you do the data alignments? All that kind of stuff. So these are all the things around it. Okay. Now, all I can say, and this is why we actually decided that we clued in and we said, there's no way we can do this by ourselves. This is really rethinking everything in software engineering. Okay. So, we wrote the paper, but in addition to that, we actually started multiple initiatives. So first, we started this AI-aware conference, which is going to be in Brazil later this summer in July. Okay, we started recognizing another thing: the gap. If you thought there's a gap between academia and industry was this much in classical codeware, the gap between academia and industry now in this FM era is way, way bigger. And there's very limited access to compute power, and there's very limited access and feeling what the real problems are. Okay. As well, working now as of recently as well, we started kind of talking to the rest of the industry. So there's a new initiative focusing primarily on RAG apps called OPIA. They're trying to bring a lot of players in the industry in that, and then kind of going back from as educators, how we can teach students on that. So that's the big things we've been working on. So this is the Create SE for AI team, where it's just primarily focusing on education. Okay, so this is for a big grant from Insert, kind of on a training grant. This is where kind of was Intel, Anyscale, Llama Index, Red Hat, and many other industry leaders trying to really standardize everything in this domain. Because the only way we're going to standardize it and to make this grow the same way, for example, database grew, is we need to have standard interfaces and standard architectures and blueprints. And then as well as part of the AI-aware kind of initiative, the kind of conference, we brought in a lot of kind of industry, academic leaders and industry leaders trying to figure out what it means the future we're going to be working on in this. Okay, so that's kind of some of that. The other thing is, so there's the first ACM International Conference on AI-powered software. So Jaya is here, and where's Dai? Dai is somewhere here. So basically, the 2 program shares it here. Okay. So if you have any questions about that conference, it's going to be a super awesome conference. Please, do attend. And it's going to be on the beach, so it's going to be even more fun. Okay. So yeah, so that's kind of my quick run through about the future of software. Okay. So thank you. Happy to take any questions.
Hey, yes, I'll project. I wanted to challenge a bit the idea that we're going for a high-level translation from like a higher-level programming language to a lower-level one, like assembly. It feels more that foundation models give you a higher abstraction through natural language. So you have like a rule-based engine. But we as humans right now are crafting everything procedurally in it. If I need to do chain of thought, I need to kind of encode it in my prompt. And the translation that I foresee, I guess, to challenge part is it's more akin to the translation of going from like a declarative language, Prolog in PL or SQL in databases, to like an execution engine part, as opposed to like a higher level to lower level deterministic translation.
So you're saying basically, you agree that we're going from something high to low, but you don't think we should be going, you're not going that low?
I'm saying foundation models introduce a higher abstraction, which is like a natural language. And the translation, or the tricky part about them right now, is we're procedurally describing what these rule-based engines should do. Which is more akin to like a declarative languages as opposed to like a Python to assembly.
You agree you're doing translation, but you disagree if you're going too low.
I'm saying
you're going this way. You think you're just going this way?
Yeah, I'm saying it's like a logical execution of what I want, declaratively, to like a physical execution of operations.
Okay, so this is my view. It's a bit crazy. Okay, I think the foundation models are a new type of SQL. Okay,
So we have a CPU, we have CPU, like an XPU, so we have CPU, we have GPU, and then now we have a foundation. Okay. So when I use the word assembly, it's basically the thing just above that XPU that you work with, right? Now, whether you're going this way or that way, we'll keep that for, you know, for the break. I believe you're going to be silent. Okay? There was a question at that.
Thank you, Ahmed. Masood here from LLC. Very interesting talk. So, technology is going to change, but one thing is, I think, is still going to be there. That is the change of requirements, because so the requirements is a kind of, let's say, reflection of human imagination. So over time, requirement will change, and in the traditional software engineering, we know that when the requirement changes, we can simply modify certain part of the code to reflect that. So with this new idea, let's say agentware, FMware, how this evolution is going to take place? What do you think?
Yeah, unfortunately, we still have to deal with humans. So they're the weakest link, okay? And the reality is this is probably the most important time in requirement engineering, because as much as we even have GPT-50, if GPT-50 doesn't understand what you want, it won't give you what you want, okay? So I think one of the big things we talked about in the paper as well is the importance of figuring out foundational models, agents that actually talk with human and do that exploration with them. Now, the beauty is the loop, you know, so today, a lot of the success of software comes from good requirement engineers and specifying requirements. Now, when you go specify, go down the development, and like 6 months later, you discover there's a problem. But imagine now that 6 months could be done in 6 weeks. Then you go back to the human and say, you know what, these two requirements, they're not actually adding up. And I implemented both systems, and this is what's happening, right? So the key thing is requirement engineering is going to be a very key moving forward. Compilers, not a big business to do these things.
Yeah, and you also said that the code wire and the AI wire, both will coexist. So do you think that the FMware will be applicable for certain type of application, whereas the traditional code wire will still remain for certain application domain?
So, you know, so basically, you don't bring a rocket launcher to this part of it. So your own type of software will exist. I'm not saying this is the end of codeware. It's another tool that exists that will enable people that have less experience in writing assembly to actually participate in software development. And the key point here is to get people that are not experienced to work in software development, there's a lot of safety nets that need to be developed by software engineers to make that possible. Okay, so it will still exist. All exists now. Yeah, some domains you can do it all with, for example, like artistic programming. You might be able to do 80%, you know, with foundation models, but the blur function, probably not a good idea to implement it in a function. You implement it down and, you know, do it, right? Thank you.
Hello. This is Barney from
see,
University of Saskatchewan. Yeah, I'm also from Queens. I did my PhD from Queens. Yeah. So in machine learning models, explainability is a hot topic. Like you need to explain the model output. But in your challenges, I don't see the explainability is an issue. Why we didn't consider explainability?
Oh, I skipped that part, so it's observability. It's an observability. Yeah, and I think the biggest challenge is because if there's no code, it's even hard to even, what do you explain it? Because there's no code. Like if 5 agents interact together and one agent in the middle did something wrong, and then now the thing is not producing what you expect. If you actually run it again, that agent might not interfere in the right way, and you might totally, you can't even rerun it. It's totally unrepeatable.
That means you are saying we have to trust the model.
No, I never said you. I guess somebody said it. You don't trust anybody. I don't trust anybody. We need to put the infrastructure to enable observability. Today, the whole industry is doing observability, but the way they're doing it is just they're telling you how many GPT calls you're doing and how's the cost of the calls. That's not what we really want. We want to be able to really understand the rationale of the model. What complicates things, if you tell the model, do what you're doing and tell me why you're doing it, it will actually give you different results. So that's even what's worse. Yeah. So there is a question behind your exam.
Hi, thank you, Professor, for this wonderful talk. I'm very new on this topic, but you mentioned C for degree of controllability. With that, I understand you are mentioning about keeping human in a loop in this. So my question is for debugging FM, where should I put myself so that I'm able to debug these models perfectly? And my second question is, as a researcher, how do I create FM without depending on the open source LLMs available? How I will be able to create something like that? So these are the two questions. Thank you.
So first is, I think you should use every model that's out there, right? And I think just only using GPT-4 or 4 or whatever is not the right thing, right? For different reasons, capabilities reasons, right? Cost point of view, latency is another problem, right? So you should use everyone. Now, debugging, the honest answer is we're trying to figure it out.
Yeah, so where do I keep myself is the question of researching.
Well, so that's a great person, it's a great reason to attend AIware, okay? And a great reason to do research in debugging. But all I can tell you, so the debugging thing, literally we've been discussing in the last month. We don't know how to debug them at this moment. Like, we know how to debug promptware, but once we started building pure agents that are fully interacting, we just discovered that when something goes wrong, it's very hard to debug.
Yeah, and also depending on open source model to create FMS, because we have very limited access and control to that, we cannot completely change, for example, if I use GPT-4, I can just access the API and create something out of it, but I cannot change the internal stuff the way I want to do. So in these kind of restrictive scenarios, how do we create useful FM foundational models that can do something really cool stuff in software engineering?
So remember the analogy I did that it says just a different type of XPU. So there are people that make their own CPUs and there are people that use CPUs. So I think 90% or 95% of the world is going to be the same way. You use the built-in thing. And there's 5% that actually will build their own. And if you're going to build your own, you'll figure out ways to bring the money for that. But I would say for us at least focusing on the 95 would be a good start.
So let's have one more question and then we're.
The one in the back there. He's been having it up for the whole time.
That's all right, I'm patient. So I'd like to zoom out a bit because I like this idea of functional models as like a calculator for software engineering. So from if you think that like may not be as paramount anymore, we have these functional models to serve these needs. But we need to replace mathematicians, right? And we've got calculators. What do we think is like the base primitive knowledge that students need in order to use these systems? So we're still teaching students how to, write for loops and if statements and write code essentially, right? That's valuable for them as becoming engineers. But now we're in a different paradigm. So what do you think that base set of skills are that people are going to need to interact with these systems?
Yeah. So in my opinion, code was never the end. It was just a mean to the end, right? And the best developers, the best students are actually the ones that have a clear brain and can logically think and do logical decomposition, all that, right? So we need to have more emphasis on the logical decomposition of the thinking processes over just pure coding, right? Now, that doesn't mean that students only need to study logic and know developing systems. So you still need to develop systems, but the emphasis here is actually on the logical thinking. That's why, for example, at MIT and a lot of the big universities, they don't teach the classical programming languages, just pick a weird programming language because they want the students to focus more on decomposition of thought and kind of, I would call cognitive architecture.
Excellent, thank you. Let's have another. Oh.
Thank you.
Okay, so our next speaker is Xi Zhang from King's College London. She's a professor at King's College London, formerly a research fellow at the UCL and a consultant for Meta. She earned her PhD from Pekin University, and her research spans software engineering, software testing, AI, LLM, AI trustworthiness, and she has a lot of publications in top venues, ICSI, ICLR, and serves as like ICST and AI steering committees, and named a top 2023 Global Chinese Female Young Scholar in this interdisciplinary AI, and she won a bunch of amazing awards, including like Best Paper Awards from top software engineering. So without further ado, I'll pass it on.
Thanks for your introduction. Hello everyone, it's my great honor to have this opportunity to introduce my recent work contributions on for assessing and improving AI systems. Although it's a lot of pleasure to give a talk after Ahmed. Yeah, so it's more introduction about myself. My academic name is M. Xiang. There's a lot of people asking what M represents, so I'm just going to use this opportunity to explain. So M is my middle name. It represents Marina. The reason that I have a middle name is because my original name Jiezhang is like so popular in China. There are more than 250,000 Jiezhang in China. So you can imagine my life. So I have to add a middle name so that people can find me when they Google my name. So my research interest is at the intersection between software engineering and AI, and we know there are two directions, software engineering for AI and AI for software engineering. I work on both directions, and now it's actually more of a loop. So I especially focus on the trustworthiness of software and AI, so I work a lot on software testing, and for AI, I work on the fairness of machine learning classifiers. And nowadays, everybody is working LLM, and I'm the same. I work on LLMs for code. So, for example, using different agents to collaborate to generate code, and also benchmarking and improving the efficiency and fairness of code generated by LLMs. Also using LLMs for different tasks, such as mutation testing for localization and program repair. So, for example, we recently have a tool called Agent Coder. According to papers with code, the leaderboard, our tool now ranks first on the human val benchmark for code task. But because Ahmed mentioned the validation concern on human validation, so I added the second slide during his talk. So on the knowledge set, our tool ranks first. Yeah. This talk is about mutation for AI. So mutation is very related to traditional mutation testing. So can I ask how many of you have heard of mutation testing? Oh, I think maybe half of you. I will still briefly go through this technique. So if you have watched the film Watchmen, so actually they ask a very interesting question. Who watches the Watchmen? And in software testing, we have a similar issue. What tests the tests? Which means that how do we know that the test cases we have are adequate and strong enough to detect the bug on the software, right? That's what mutation testing does. So we have the original program. When we can mutate the original program, like put some injected force in it according to some rules. We call them mutators or mutation operators, and then we generate a lot of mutants which are being proven with injected force, or we can think that they are simulated force, right? So once we have those simulated force, we check whether the test can detect those simulated force. If they could, of course, they're okay. Otherwise, they're not good enough and they need improvement. So mutation testing, the direction is really my first love in my research career. I still love it very much because I realized that the mutants, they are actually very, very powerful. The reason that they are very powerful is because they bring changes, and we know that only by making changes we can make everything better, right? But in traditional mutation testing, we ask the three big questions. Where do we do the mutation? It's only mutating the source code. How do we do the mutation? It's based on human heuristics. We call them mutation operators. Why do we do the mutation? We basically want to assess the text. But because mutants are very, very powerful, and I start to explore the power of mutants beyond test assessment of my piece variation. For example, I mutated my own name by adding a new name, right? I also mutate pentenes because I'm a big fan of pentene, and although my biggest motivation for pentene is to save money because by muting the lending is like too expensive. So what I do is that I find some online existing art pieces, I perform some mutations on them so that I would have novelty, and also I can claim that I can create something. But seriously, I'm applying mutation to improve the AI system. So in this talk, I will briefly introduce 4 aspects of this direction: testing and improving machine translators, and also validating machine models and benchmarking AI fairness, and also improving AI fairness, all using mutations. But due to time limits, I won't go into each direction. I just want to show you the power of mutants. And if you are interested, welcome to read the full paper and also talk to me during today and also tomorrow. So the first work is mutation for testing and improving machine translation. And it's a work published at TXE 2022 and also 2020. So translators, because we speak different languages, right? So we use a lot of machine translators such as Google Translate. And the problem for users of machine translators is because they usually have no idea of the target language, because they can't judge whether the translation is correct or wrong. So if you look at these 2 pictures, the first picture is the Chinese menu, and the Chinese characters is actually roasted gluten. So in English is roasted husband. Really horrifying. I'm sure the designer of this menu had no idea of the English, right? And actually the designer over-trusted the machine translator that they used. So the second one is Chinese sign. So the warning actually says, watch your step, but the English says, sleep and fall down happy. So these are like translation disasters really made by machine translations. And there are also some fairness issues too. So a real example that I found on Google Translate several years ago. They have fixed the issue, but you can easily find other issues. So if I ask Google Translate to translate then do good research in computer science into Chinese, then good is translated into very good. If it's women do good research in computer science, good is a lot. So it's the same for male students and female students. If it's male students, good is very good. Female students, good is a lot. Obviously, very good and a lot, I know, obviously very different. And as a female researcher, I don't feel comfortable to see this kind of translation difference. So how should we handle these translation issues? We first need to detect them. And traditional methods, we usually rely on manual inspection, right? They either have some employers to check some translation, or they rely on the reports from the users. And then they would collect more training data, modify their algorithm to improve the machine translator, retrain the model, right? And to try to repair the translation issues. But this kind of model retraining methods, they have also limitations. For example, they're very, very expensive by collecting more data and retrain the model. And also, it's not online because model retraining takes a lot of time. And after you retrain the model, most of the users, they already use those horrible translations in their life. Another big issue is that it's not box specific, because model retraining is very difficult to control. If you want to fix some bugs, you retrain the model, you bring a lot of new bugs, right? And so other well-formed translations will be affected. So that's why in this work we propose a new approach that does not need model retraining. So we first want to test the translations and we use mutation. We mutate the input sentences. So what we do is that we replace a word to its context similar word, for example, men to women and apples to oranges, to use some examples. And we tried word to work and also bird. And nowadays, obviously, we can use language models, but we haven't tried that. And once we have those original sentences and repeated sentences, we compare the consistency of the translation, so the and change the parts. If there is inconsistency, obviously one of them is not good enough, and the consistency is also not good. It's a big issue, right? So we also want to repair the translation issues because detecting issues is easy, but repair can be difficult. So what we do is that we create more mutants for the input synthesis. Each mutant would have a translation. Then we would rank the translation of these mutants so that we can have a better translation that's created by those mutants. And then we have the translation of the mutant and translation of the original translation. We would patch the, we change the original translation using the translation of the mutant based on how we get the mutants, and this way we repair the original translation. Just in a kind of a poster processing way without model retraining. So our results show that Google Translate has like more than 1/3 inconsistent translations based on our experiments, but our repair could repair half of those translation bugs we detected, and also it's very, very fast on our own machine, which means for Google, for example, for the big company, they can make it much faster, so that users won't even realize that we are secretly testing and repairing the translations on the back, so the users will get the repaired translations, right? So it's a black and gray box, and does not need model retraining, so it's very cheap, it's very fast, it's real-time test and fixing, and also it's flexible because it only targets the binary translations. We don't change other well-formed translations. So to summarize this work, where do we do the mutation? We don't change the code. We mutate the model inputs and model outputs. So how do we do the mutation? We did context signal replacement for the purpose of testing and improving machine translation. So the second work is mutation for validating machine learning classifiers. And it's work published at Eurocomputing last year. And we use the machine learning model all the time, so we need to validate that when we train the model, right? And there are basically two directions of validating a machine learning model. One is applied machine learning, so we use also sample validation, for example, cross-validation and test accuracy. But these methods, there are lots of limitations. For example, the data can be insufficient, and also the test data can have similar bias to the training data. So you can't really detect the bias using the test data. And also, lots of people just use the same data set and they overfitting to the test data, and it does not reflect outer distribution generalization. Another aspect is statistical machine learning, such as basic dimension and Raymaker complexity. But statistical methods are actually now very behind the development of AI, and they are very difficult to compute in practice, and also they just provide very loose bounds, so not very useful. So that's why we think we need metrics to complement these existing metrics to validate models. So that's what mutation validation does. The idea is quite simple and straightforward. So imagine we are teaching this baby what is a cat, what is a dog. So give this baby a bunch of cards with labels. So we tell the baby, okay, first one is cat, and then dog, dog, cat, dog. For the last one, we change the label. We say that it's a dog. We tell the baby it's a dog. So the baby is like building the baby's own training model, right, in the brain, right? So in the second round, we give these cards to the baby and ask the baby what animals these are. So if the baby says the last one is a dog, do you think the baby is smart enough? So maybe not. If the baby said it's a cat, so the baby is not biased by the incorrect label, right? Which means the baby is not memorizing the labels. Instead, the baby is really learning the patterns in the data, reading what is dog and what is cat. So that's the idea of mutation validation. Quite simple. It's just mutate the training labels and see whether the classifier, whether the learner is biased by the noise in the training labels. And then we would check the training accuracy difference. So here is a metric calculated based on statistical machine learning. So basically, we calculate the mutation validation score based on noisy rate, which is the ratio of labels that we mutate. and also based on the training accuracy of the model trained on the original training data, and also the model trained on the mutated training data. So we check their differences, and we use this one to calculate the score. To just show you some interesting results, we know that a good classifier should reflect the data distribution patterns, right? For the classifier problem, for example, if we can look at this one, the below one, as an example. So the classifier is in tree, but the data distribution is circle. So you can see that the decision boundary of the decision tree is a square. So it does not reflect the data distribution at all. But CV and the test accuracy is that it's a perfect classifier, although the decision boundaries are completely different with these patterns. But our metric is actually not good. So the value is just 0.776. Some other interesting results is that we found that this metric captures well the degree of match. I'm sorry. Yeah, this is the first one I just mentioned. So other interesting findings are like we found that metric helps to find the simpler model with the comparative performance. And also it helps to tune hyperparameters more quickly. So these aspects actually are the last two aspects, they are very, very important for green AI and sustainable AI. Because nowadays everybody is talking like that. I don't know what's like in Canada, in UK, let's say. First priority, right? We try to build our machine learning model, how do we make it sustainable and try to use the simpler model as much as possible. So for this work, we use the training data and the labels in particular. So we just change the labels to the other labels in the or the label set, and the purpose is to validate machine learning classifiers. So another work is mutation for benchmarking AI fairness performance trade-off. And it's a work published by on 2021, so it's been code. So it's about fairness. And how many of you are working on fairness of machine learning? And three or four? That's a bit surprising to me. Yeah, so I definitely need to introduce the background. So for fairness of machine learning, we usually have protected attributes because we humans, we have lots of features. And then we have lots of attributes that are protected by law. For example, the race, the sex, the age, whether the person is pregnant or not. And then we have privileged and unprivileged group. So unprivileged group are those really at disadvantage from history. So the definition of group fairness in machine learning is to check whether these two groups, privileged group and unprivileged group, they are treated equally by a machine learning classifier, which means that when the machine learning classifier makes a decision whether it favors some group than other one. So that's the definition of group fairness. But the problem is that there is a trade-off between accuracy and fairness. So Steve talk this morning mentioned the trade-off between privacy and it's so it's the same for fairness. Everything has a price, which means that if you want to improve fairness, usually the accuracy of the machine learning model would decrease. So this brings a very interesting problem. How do we evaluate? How do we compare different fairness improvement methods? Because some methods they improve more fairness, right? But usually they decrease more accuracy as well. So how do we know which method performs better? And existing work is just to display them separately or just to realize them. But the problem is that it's very difficult to compare methods, and there is no baseline to rule out a very naive price prediction method. So what is a naive price prediction method? It's because of this trade-off between accuracy and fairness. So imagine that if you have a random guess classifier, it's just random guessing, it's not doing anything. So this person is just maybe they come up with this fairness improvement method, saying that, well, now I improve the fairness a lot because the accuracy, they're both 50%. So it's equally worse, right? It's like perfect fairness, right? But it's equally worse. So that's a very interesting case for naive biosimilarity method, but there's no baseline to rule out this one. So what we did is that we use mutation to simulate this kind of naive biosimilarity methods, which just sacrifice accuracy for fairness. So we just mutate the predictions of the model to a different one. For example, we previously predict to 1, for example, we change it to 0. And we have different degree of mutating the predictions. And we would then, by making each mutation, we would have a bias and accuracy. We would plot all the models and connect them. And then there would be a line, which is our baseline. And on the left, you can see that the baseline would classify the fairness improvement method into different regions. For example, the win-win region means that both the accuracy and the fairness are improved, and the lose-lose region means both are decreased. And good trade-off region means that, okay, there is a trade-off, but it's better than our baseline. Because any reasonable fairness improvement method should outperform our naive method, right? And then poor trade-off means that, okay, there is a trade-off, but it's even worse than our baseline. So we did large-scale improvement studies. The results are on the right, which is quite surprising to us because half of these existing fairness improvement methods, they have a poor mitigation effectiveness, and 1/3 of them they fall into the lose-lose region, which means both accuracy and the fairness decreased. And 15 of them, their trade-off is even worse than our baseline. So to summarize this work, we mutate machine learning model outputs model predictions, and we just flipping the predictions and for the purpose of benchmarking the performance and fairness trade-offs. So the last work I want to share is the mutation plus ensemble for improving AI fairness improvements. And it's a work, it's a work published at FSE this year. It's called Neurohair. It's done by my PhD students in Seoul. So actually, we are very familiar with ensemble method, and in machine learning, we have random forest, for example, where we classify the training data into different subsets, and then each subset could create a model. And we have lots of models. We could ensemble those models to form the final predictions, right? So this is the traditional ensemble methods in machine learning. And in bias mitigation, we also have ensemble methods, but they just ensemble different bias mitigation methods to improve fairness. For example, there is fair way and fair mode. But actually, we think there are new ways of ensembling with mutations. So what we can do is that we mutate the training data. So once we have a mutated training data, we could create a new model. This way, we could ensemble this kind of mutated data created model with the original model to ensemble to make the final predictions. And this is actually very similar to Elna's talk this morning, the use of synthetic data, although the purpose that she introduced was for privacy, but here the purpose is to improve fairness. So the idea is again very straightforward. We have the original data set, right? We have the data set has sensitive attributes, which may have lots of bias due to lots of reasons, for example, historical collection and other reasons. And we could mutate this original training data by flipping the sensitive attributes. For example, we change the dark color feature into non-dark color. This way, we would have a new training data, and this new training data produce a new model. So we designed some ensemble strategies to merge these predictions of the mutated model with the original model. And our ensemble, there are different ensemble strategies. For example, we can use to calculate the average value of different models, or we can design some adaptive strategy. So we select which model result to use based on different contexts, right? And our results shows actually a surprisingly good. It shows that it outperforms all the existing other methods. So it has the largest ratio of win-win region and portrait of region. You still remember that our design classifies the variance improvement factors in group. And it performs well on almost all the algorithms and different data sets. And also it proves fairness in the best way, but also result accuracy in the best way of performing other methods. So to summarize this work, we mutate the training data to create new data sets, and we just flip the sensitive attributes to create some kind of synthetic data, right? And the purpose is to improve machine learning fairness. Right, so just to conclusion part is that in this talk I introduced 4 of my works on using mutation for assessing and improving AI systems, like machine translation systems and in general machine learning classifiers, and also benchmarking and improving AI fairness. So maybe in future what we mutate is ourselves, is our brain. So that mutations are even more powerful. So I don't know whether you have read this book. It's called A Brief History of Tomorrow. You can hands up if you have read it. Right, 2, I don't see 2 people. It's by the author of Science. And if you haven't read, I strongly recommend the book too, because it would make you more confident about the future if you're very anxious for the moment. So the author in an interview, the author said, we are in the process of becoming gods. And I believe that in future mutating humans, mutating ourselves will contribute a lot to this. But the big question is that how do we deal with our new godlike powers? Yeah, so that's all for my talk. Thank you very much.
Okay, thank you for a great presentation. I just had a question. Like, how do you know the number of mutations that one should conduct on a training data set? Yeah, how do you know the number of mutations? Like the proper number of mutations that you should conduct on a training data set?
So are you talking about specific words? Last one. Yeah. Last one, I think the slide I just gave you an overview of the idea of mutating training data. Actually, in the work we just perform one mutation. So we just use one mutated training data. But I think there are lots of opportunities to explore generating more mutated data and ensemble results.
Yeah, does that mean like that you mutate one instance in your training data set?
No, we mutated the features, the attributes. So we mutate all the sensitive attributes. So we mutate. So each mutant is trained data, is a new trained data.
Thank you.
So how did you get to, how did you develop this?
How did I develop it?
Yeah, interest, like what brought you to?
That's a very interesting question. Yeah, I actually need to think about that. I think it's the first 2 topics that I did when I started to do research when I was an early PhD student. The first one is mutation testing, the second one is metabolic testing. Then I realized that, okay, mutation is very changing, and metabolic relation of the relationship between the input changes and the output changes, and we are like a perfect match. With one very changing, one type of relationship that changes the behavior itself. Isn't that like super powerful and then that's like embedded in my mind. And now I kind of form the habit of thinking whether meditation can solve a problem when I see a problem. For example, this morning when I listened to the talk of privacy, I was thinking whether we can use meditation to improve the privacy issue. And I just added that to my idea list. I don't like that on the real question. I don't really like think about that seriously. I kind of very negative.
It's crazy when you do research in the field, you start seeing it everywhere. Like you were the talk.
Sorry.
Oh, I said it's funny when you do research in a specific field, you start seeing it everywhere.
Yeah, I have a broad research.
It's really cool. Thanks.
There are different techniques to generate mutant. Did you follow some specific technique? Which techniques? For example, there are crossovers and other techniques in genetic engineering to create mutant. Did you follow some specific technique to generate the mutant? And my next question is, did you check that different mutant generation techniques may have different result in research?
Yeah. That's a great question. I think that's a big difference between traditional mutant testing and the work that I introduced. So traditional mutant testing are based on human heuristic, human designed mutation operators. But the work that I introduced, you can see that there are applications in different domains, and then each domain they have their own features. So I think I tried to think about whether I can borrow the mutation operator ideas from the traditional mutation testing, but because what we are mutating here is not the source code, it's a lot of training data and inputs and outputs. So what we do is just we really design our own mutation operators that are different from the traditional mutation operators. And we would explore different operators and report the results and see which operator, just show their results and see which operator performs best in our evaluation. That's what we really do.
Suppose for a feature vector, there is a feature vector having a 3 element 1, 2, 3. How the mutant of this feature vector would look like? 3 to 1, 2, 1, 1. Is that something like that?
You are talking about the last word.
Feature vector.
Yeah, you are talking about the last word I introduced,
Yes.
Right? So the last word is a bit special because for machine learning research domain, they really treated the sensitive attributes as a binary problem because most fairness metrics they are based on binary roots based on because they are checking the difference between two roots. So really the feature is modify the original feature a little bit to make the feature binary. So it's just a big feature.
Thank you.
Thank you. There's one next question, it's very specific for the evaluation. So for example, here for model, we all know that the model has different performance. So we say they have a significant variety in performance. And for you measure the fairness, so I would assume if the model have a lower performance, it's better in fairness because it always gives wrong answer. So how you consider this into the comparison result?
So you need a comparison of
the different level of fairness.
Yeah, I think that's an interesting question. We didn't do that. But I think it can be easily done by analyzing the results.
Yeah, but I mean, one model has a very high accuracy, but I can say your fairness measurement is correct. But if a model always have a 50% accuracy, so for man, the woman is always give the more or less the same. So the fairness of this model would be higher. So somehow even it is biased.
Yeah, I think that's a very interesting point. I think indeed for different models, maybe we should think about the specific feature for each model and design different strategies.
have a quick question. So for your data set, what type of data you are considering, structured or unstructured?
Which word are you talking? Sorry, I can this
Can
one.
you go back to the last slide?
This one? Do you mean the
And the mutants, where you are
mutating the sensitive?
assembling the mutants to the data set. And
Yes.
you are creating.
This one?
Yeah, so in the data set, I'm just wondering about the data type, is it structured or unstructured?
Yeah, it's again a common practice in the machine learning fairness research domain. So the data sets, they are usually tabular data. Yeah, because they are targeting classic classifiers and also deep neural networks that handle tabular data. But like other types of data, like text and images, they usually, yeah, they are like kind of a bit separate from tabular data fairness research. But
Because you were showing the picture like where a kid is trying to learn from the pictures of dog and cat, so the kind of unstructured. How we would fit that kind of unstructured data.
yeah. I think for those we might need to mutate the images, so obviously it's editing techniques. But I think it should work. It should be adaptable to other types. It's just because tabular data is used by all baselines. Thank you.
Thank you for the presentation. So my question is more like mutation, because when I think of mutation of code, I say code basic, mutate the code, test the code again, paste tested, these the mutation positive or negative. If it's positive, mutate again. But here, I didn't really quite understand how many mutations you do and what is the threshold when we stop. So how we validate the mutations, if they're good mutations or bad.
There indeed can be good mutations and bad mutations. So usually I think mutants are bad mutants because they're simulated false, right? And but sometimes the mutants they're neutral. For example, in the machine translation one. The machine translation one, if we just mutate males to females, for example, there are no good mutants or bad mutants. And then I think for the other two words, for the sensitive ones, it's difficult to say whether if the sensitive attributes make a good mutant or bad mutants, because we know that the resulting data is biased. Yeah, there is an issue when we collected the training data, right? So yeah, so I would say that it's still neutral. So I think it depends on our target, and we don't necessarily have to say whether the mutation are good or bad. The important thing is our target, and then we do the mutation as long as we get the target.
Okay.
Maybe one last question.
Thank you. Maybe.
Hi, my name is Sigma. I'm from Townhouse University. So recently I started working with mutation testing to create synthetic data for software debugging for deep learning system. So my question is, as the data grows and the complexity of the data set grows, how do we scale this? Because mutation is based on some heuristics. And so if the problem becomes more complex, for example, there are some mutation operators for CNN models, like buggy CNN models, convolutional neural network models. Now there came recurrent, then there came attention-based, now there are transformer-based models. So there needs to be different mutant operators, and it keeps growing because DL is growing exponentially. So how do we scale this? Because it's some heuristic. How do we optimize so that like we can do selective mutation process?
Yeah, that's a really great point. So the scalability of mutation testing is important for traditional testing, but it's also very important for applying mutation to every domain, I guess, right? So I think one strategy is probably when we do mutation, we don't have to mutate the whole thing. For example, when we take the data, we can even just mutate a subset of the data. And this way we get a new model, we can do the ensemble. Just use my last work as an example. So I think that's one strategy. Another strategy is that whatever we want from the mutation, probably we can develop some way to predict the results of the mutation so that we avoid the expensive, for example, execution procedure for the mutation. Just like I have a work when I was a PhD called predictive mutation testing. So we use machine learning, or nowadays we can use LLMs to predict the results. In this way, we can save the cost. So,
Thank you so much.
And also, please see my poster below. There is a solution, like we have a framework to process such a mutation procedure.
Oh, okay.
Thank you.
Thank you. So we are going to have a coffee break, and please come back by 4. Thank you.
What's your question for the technology one? It's mine. I'm gonna ask. Tomorrow.
Seems everybody using their own camera. Is it possible?
Do you know even Karen is here? Did you see Karen, the next speaker?
Yes.
I think I recently
Yeah, I agree. I mean, but I agree. Yeah, so the long review and always thought of why he wasn't expressed more. But now, reviewing of the engineering.
Hello, everyone. Welcome back. I think we can get started. Cool. So our last but not least speaker of the day is Karim Amari. He's a research engineer at Distiller Yard. So he flew all the way from LA here. We're very honored. Thank you. He specialized in building LLM-powered structured querying and optimization systems for Fortune 500 customers. Prior to that, Karim was a research associate at Argonne National Laboratory, where he worked on synthetic data generation, and a simulation engineer at the NASA Langley Research Center, where he worked on simulation development and analysis. So without further ado, let's have a round of applause for Karim.
Thank you very much. Thank you very much for the invitation. Very happy to be here. My name is Karim. I'm a research engineer at Distill, though after Ahmed's talk, I may change my title to FMware engineer, because I do believe that this work is very closely related to this notion of FMware. In particular, I'm going to be talking about the construction of a text-to-SQL engine. To begin, I'll very briefly motivate the work. We could think of motivation from a wide variety of directions. I'll be talking about motivation from the user's perspective and motivation from the enterprise's perspective. So this is likely not the crowd to make this argument to, but working with data can be painful. For the average analyst, working with data means learning a new language to analyze that data, learning a new language to access that data. And so very quickly, the role of the analyst can become cannibalized by this notion of data access, data exploration. In constructing such a system, what we aim to do is transform the role of the analyst away from data exploration and towards insight exploration. This is very nice, but ultimately it's not going to pay the bills. It's not purchasing the OpenAI credits. Instead, enterprises want to see return on investment. So if we think in those very nasty terms, these are actual numbers from a Fortune 500 client. We see that the gains associated with construction of such a system are on the order of tens of millions of dollars. And so regardless of whether we're thinking about this system, whether we're thinking about value from the perspective of the enterprise or from the perspective of the user, it's clear that there's a lot of value to be had here. So what exactly are we building? Text-to-SQL is often framed as a problem in translation. That is to say, the same way you can go from English to French, French to Spanish, you should be able to go from English to SQL. However, I would argue there are two key differences, and these differences will ultimately dictate our approach. Difference number one is what I'll refer to as this radius of accepted outcomes. That is to say, if I was to translate something to French, and my translation was not exactly correct, a native French speaker on the other end will still likely be able to understand what I'm saying. In fact, this translation is incorrect in more ways than one, but I'm sure all the French speakers here could still reasonably parse out what I'm trying to say. When we're translating to SQL, we need to be syntactically correct and we need to be semantically correct. That is to say, we need to execute properly on the underlying database, and the data we retrieve needs to be the data we intended to return. So as such, this radius of accepted outcomes, or the notion of correctness, is much more narrow when we're translating to something like SQL than it is when we're translating to another spoken language. Second key difference is what I'll refer to as the radius of potential outcomes. That is to say, how sensitive are we to the context within which we are operating? If I'm translating this input, what were total profits in Q1 2019 to French? In one context, I work at a car dealership, In another context, I work for a biotech firm. Well, irrespective of the context, the correct translation is likely to be the same. And when we translate to SQL, we'll be working with different tables, different columns. The notion of profit may surface in different ways. So as such, we are much more contextually sensitive to the data we're working with when translating to SQL than we are when translating to a spoken language. So put together, what we're saying here is that the probability of properly going to French, given some context and some English input, is effectively the same as the probability of going to French, given that English input alone. Whereas the probability of probably going to SQL, given some context and some English input, will rarely, if ever, be the same as the probability of going to SQL from that English alone. So the upshot here is context matters. That is to say, you can go to a translator and translate from English to French, but you cannot translate from English to SQL because you do not have the context required. And so text to SQL, sure, in some ways it's a problem in translation, but even more so, it's a problem in leveraging this context to perform this translation. And we find ourselves in this incredibly opportune position with the introduction of large language models, and that large language models are particularly adept at this task of leveraging context. So if we look at the landscape of text-to-SQL solutions over the past 5 years or so, we see that in recent years, this landscape has been dominated by these LLM-based solutions. And if we look at the underlying approaches, we've gone from leveraging these sophisticated NLP approaches like abstract syntax trees, sketch-based slot filling, semantic parsers, to instead very simply providing the schema, maybe some examples, the question, and getting back an answer. And so we've gone from leveraging these sophisticated approaches on top of very simple models to instead leveraging very simple approaches on top of very sophisticated models. And this sort of paradigm shift exists not only in the context of text to SQL, but across a wide variety of domains. And so naturally, you may ask the question, why not leverage these early sophisticated approaches with these new sophisticated models? I hope to touch on that question through a discussion on a set of design principles. I'll then apply these principles to our approach and then talk about some additional components we build on top of our core engine to make it as usable as possible. To begin, let's take a step back and revisit this notion of context. What do I mean when I talk about context? You can think of context as the environment around the question we're asking. So if I ask the question, what were total profits in Q1 2019? I may be operating within the context of a car dealership. And so within context exist answers to questions like, how is PPV calculated? What is a car? How many employees do I have? Where am I located? There's a difference in these questions, and that this notion of PPV, which I've entirely made up, exists outside of the pre-training of the model we're working with. So as such, it is extrinsic knowledge, whereas the notion of a car is likely to exist within the pre-training of the model we're working with, and as such, it is intrinsic to the model. And so the task of leveraging context is a task in transforming this general purpose model to include this associated extrinsic knowledge and to prioritize this associated intrinsic knowledge. The way we do this is through the construction of a set of operators. Think of operators as tools that take in information from context and present it to our model in a useful way. So a very simple form of an operator might be an operator that takes in all of the raw information from context and formats it into nice and neat blocks. Other forms of operators could be augmentation operators, retrieval operators, standardization operators, chain of thought operators, so on and so forth. Now, in practice, rarely, if ever, will we use a single operator. Instead, we chain together 3, 5, 10, 15 of these operators to complete a particular task. And there's a subtle danger in chaining together these operators in this way, that let's say the original probability of success of our system without any operators is 90%. But we're greedy, we want to get to 95%, so I introduce 3 of these operators. Each of these operators also has a probability of success of 90%. Well, by virtue of chaining together the operators in this way, their probabilities become multiplicative. And so the overarching probability of success of our system drops from 90% to 73%. And so the first design principle is hopefully an obvious one, an intuitive one, but that is we should construct our operators to be of much greater probability of success than the original overarching task. A simple example of this is what's known as schema linking. Schema linking is the process of reducing our original schema down to the relevant components. If we over-filter our schema, we may not have the columns necessary for generation. If we don't filter our schema at all, we're introducing too much noise to the model, and so that will also harm generation. And so there's this subtle optimization task that needs to occur for each of these operators to get it in the best possible form. So returning to this question, why not leverage the early text-to-SQL approaches with these new text-to-SQL models? Well, the answer lies in this first design principle. That is to say that these early approaches are so inflexible and narrow in their form and applicability that the probability of success of these operators across a wide range of problems is fairly low. Let's say, for example, we want to use this early sketch from the late 2010s for the construction of a query. In practice, our queries look something like this. Oh, that's not rendered too nicely, but our queries are exceptionally complicated. And so I'm not a betting man, but if I was a betting man, I would bet against this sketch being able to handle a query of this level of complexity. And so if we want to use these early approaches, or just generally when constructing our operators, we need to put our operators into a flexible form, such that they can handle an arbitrary level of complexities. Additionally, and crucially here, we want to make our operators contextually complete. This notion of contextual completeness arises out of a concern known as the mismatch problem. That is, the representation of information in our input space differs from the representation of information in our output space. In this case, in input space, we're talking about natural language. In output space, we're talking about SQL. And so the mismatch problem posits that at some point in this translation, we need to make a leap from natural language to SQL. If we can make our operators contextually complete, that is, include information from both the natural language space and the SQL space, we can mitigate this mismatch problem by minimizing the distance associated with this leap. Very simple example. We provide a set of instructions to our model. The standard way to provide these instructions might be in natural language, and this will work for the vast majority of implementations. However, given that we are operating with this mismatch problem, it's important that we include the instructions in both natural language as well as with pseudo SQL code. So we're representing the same information in the input space and the output space. So the second design principle is that we should construct our operators to be contextually complete in this way to mitigate the mismatch problem as much as possible. With this, naturally might come the question, if we're including all of this information about the input space, about the output space, are we not ballooning our prompts? And how does this affect response time in turn? To answer this, let's look at the following example, where on the left, I'm providing the schema, some instructions, some formatting, 1,000 examples, whatever. Our input context length is many thousands of tokens. From this, we generate some SQL query. Now let's say I take that SQL query, I'll provide it to another model, and I'm just doing an identity operation. I'm taking the input, providing it as output. Well, irrespective of the input prompt, both of these tasks will converge in right around 13 seconds. That is to say, even though the task on the left has 20 times the input length as the task on the right, they both come to fruition in 13 seconds. And this is because this, that's fine, that's fine. I could project it. Can you guys hear me in the back? Okay. Okay, can you guys hear me? Very nice. The reason this is true touches on the third design principle, which is that response time scales with output length, not with input length. And so that is to say, we should be sufficiently greedy with our input prompts, such that they are contextually complete, while being cautious with our output lengths. So put together our three design principles. First, our operators should be of much greater probability of success than the original overarching task. The way we can do this is by making our operators contextually complete. And we can do this confidently because we know that the response time scales with the output length, not the input length. Okay, heavy lifting is over. Now we can have some fun. Let's talk about our approach. This approach, I think, is FMware in its purest form. The approach is comprised of almost entirely model calls. We have a few points of retrieval that are not based on models, but in general, almost every component you see here is based on a model call. Starting with preprocessing. The preprocessing step involves taking all of the raw information associated with context and putting it into a set of examples, a set of instructions, and a representation of the schema. Starting with the examples. Recall earlier, I showed that simple sketch from the late 2010s for how we could construct queries. We want to make that more flexible. And so instead here, we'll use a CTE-based sketch where we have a set of subqueries, ideally one subquery per table, and then we'll retrieve the necessary information from each table and do the necessary calculations in the final subquery or in the final state. Now, an advantage of using a sketch of this form is that we can not only handle queries, of this level of complexity, but also queries of this level of complexity. And there's an advantage to using a standardized form like this, in that now when I present my examples to my model, there's less variance, there's less noise around the form of the query. Instead, all of the queries are of the same form. They'll have the same ordering of tables usually. And as such, the model only needs to reason about the selections required and the calculations required, and not about the form of the query. Another advantage is that we can easily decompose this form into a hierarchical structure. So we could say, here's our full query. Here are our subqueries. For each subquery, here are our substatements. So as such, we get an output structure that looks like this. So in blue here, you see the decomposed examples. Again, we want to make this contextually complete. So we'll include information about the complex terms, about the tables required, about the subqueries required, and so on and so forth. Now, the actual decomposition, so I'm showing simplified examples all throughout the presentation. Our actual examples look something like this. They're massive. And so an advantage of putting these examples in this form in pre-processing is that the user never eats the costs associated with outputting a structure of this length. Instead, we do this all in pre-processing. We eat the cost such that the user gets a better experience. They only need to retrieve these examples. They don't need to produce these examples. Okay, so at this point, we have a set of examples. Now we want to produce a set of instructions. These instructions can come from documentation. They can come directly from the examples as well. As I mentioned earlier, we want our instructions to be contextually complete. So we'll include the instructions both in natural language and in pseudosql. And then finally, we need to represent our data. And so we can provide the table names, the column types, column samples, and a brief description of each column. Okay, at this point, what do we have? We have a set of examples, we have a set of instructions, and we have a representation of our schema. The next step is for an input query, we need to identify which of these examples, which of these instructions, what components of the schema are relevant to the particular task. The first step here is a query reformulation task. So we're going to take the user input and put it into a standardized form. This is what we'll call show me form. So for example, if the user asks what were total profits for T5 Nissan salesmen in Q1 2019, we'll reformulate this into the structure show me total profits for T5 salesmen for Nissan for Q1 2019. The advantage of putting our query into this form is that now we can very easily produce variations on this query where we vary any of the components that emerge in the schema as well. In this case, we'll produce two variations where we say show me total profits for T3 salesmen, show me total profits for T7 salesmen. We swap out Nissan for Honda, Nissan for Tesla, so on. But if you look at these variations, there's one parameter that's held fixed, and this is total profits. Total profits is the calculation we want to do. This will ultimately dictate the structure of our query, and so we'll mark this as the intent of our query. Now, given this intent, we can select from our example set and our instruction set to only those examples and only those instructions which share a similar intent. So let's say we go from 100 examples, 100 instructions, down to 10 examples, 10 instructions. Now, with these remaining examples and instructions, we can re-rank using a similarity search to identify the top K examples and the top K instructions using the standardized input. The last step is schema linking. As I mentioned earlier, we have to be careful with schema linking. We don't want to overfilter. And so we choose a much more cautious approach here, where we do irrelevance-based filtering. And so for each column, each table, we'll ask, is this column or table certainly irrelevant to the task at hand? If so, we drop it. As such, we end up with a minimized schema. And then we follow up on this by doing a similarity search on all of the non-numeric columns for their unique samples. If they have less than 10,000 samples, 10,000 unique samples, we'll similarity search on those samples to identify the top 5 most relevant samples to the input requests. We'll replace the original samples with these new samples. Okay, hopefully everybody's with me. At this point, we have a set of relevant examples, we have a set of relevant instructions, and we have a minimized schema. We can now use this information with our reformulated input to generate a candidate query. First step is to generate a chain of thought plan. Chain of thought prompting is allowing the model to reason about the steps required to complete a task. It's been shown to improve model performance across a wide variety of tasks, so we want to leverage it here as well. And again, we're going to generate a plan and make that plan contextually complete by including pseudo SQL statements. But now these pseudo SQL statements are coming from the retrieved examples. At this point, we have a set of examples, we have a set of instructions, we have the schema, we have our reformulated input, and we have our plan. Now we can go about generating a candidate query. So we end up with something like this. Now, a massive advantage of working in an executable language is that you can get feedback for free. So now I can execute this query on the underlying database. If the execution fails, we treat this as a feedback message such that we can correct our query in real time. If the execution succeeds, then we get back a data frame. Now we can perform checks on these data frames. Is the data frame empty? Does it contain exclusively null values? Does the data in the data frame pertain to the input request? So on and so forth. We can get feedback, we can correct the query. So at this point, we have our original candidate query. If we needed to correct it for any reason, we have the feedback and the correction. Now we can use the original incorrect query to update our system at large. So we can try to identify where in our knowledge set did this issue stem from. Was it an issue with the instructions? Was it an issue with the examples? Are we missing an instruction? Are we missing an example? As such, we can update our knowledge set so that we don't run into the same issue in the future. To recap, we start with a pre-processing step where we take all of the raw knowledge associated with our problem and we put it into a set of examples, a set of instructions, and a representation schema. We then retrieve the relevant examples, the relevant instructions, and the minimized form of the schema and reformulate our input query. We'll pass this forward to generate a candidate SQL query. We'll execute this query, update if necessary, and then update our system at large. And on and on and on we go. 2 additional components, then I promise I'll leave you alone. The first one is context management. This engine that I'm showing here is single turn. It takes in an input query, it produces an output query and a data frame. But the actual application we provide to clients can manage context. It is multi-turn. The way we do this is by reformulating subsequent queries in the context of prior queries. So let's say, for example, the user first asked what was the increase in mental health inpatient claims for children from 2019 to 2020. They then follow up on that by asking, what about for adults? We will recontextualize this in the context of the original query. So this query will then become, what was the increase in mental health inpatient claims for adults from 2019 to 2020? And then we'll pass this reformulated query to our engine. This allows users to have this sort of continuous exploration of the data such that they can arrive at an insight more easily. Second additional component is how we're actually giving our answers back to the users. What I presented was we give back a SQL query, maybe a data frame. In practice, we provide the SQL query, the data frame, an explanation of the SQL query, an explanation of the data frame, a plot, and a simple natural language answer. The reason for this is we want users from all different domains of a particular enterprise to be able to interface with this tool. So analysts might be interested in the SQL query, business users maybe just want the answer, others maybe want a plot, so on and so forth. The way we do this is the same way we construct our text-to-SQL engine. We construct operators that are contextually complete for that particular translation. So if we want to go from data frame to natural language, we might have some instructions that contain instructions both in natural language and in data frame language. That's all I've got. Thank you guys very much. Thanks again for the invitation.
Thank you for the nice talk. So one step of your approach is query reformulation. And to do the query reformulation, that is a step that like intent detection, right?
Sorry.
Intent detection. So you try to detect the intent from the query?
We detect the intent from the input natural language query.
Okay.
Yep.
Yeah, so I'm just wondering, is there a solid theoretical way to do the query reformulation? Because in the information that you only have query expansion, query redaction, query replacement. So I'm thinking, is it similar thing like that traditional information retrieval, or is it something different for SQL query? So you need a different kind of approach for query reformulation.
So this is not query decomposition in the same way that an abstract syntax tree might be query decomposition. Instead here, we just want to represent the hierarchical structure of the query. We're not trying to draw any relationships with the query. And so in that way, it is slightly different. It's simpler than earlier approaches, but nevertheless, it works well to allow the model to be able to understand the particular clauses. So for example, the select clause, the where clause, so on.
Also, you said that you're using the result of one query and you're getting some feedback, and then you're using the feedback to refine your, that's the second query.
Yes.
How do you?
The adaptation step, are you talking about?
Yeah. So you're using the insight from the feedback of the first query to, let's say, do more fine-grained query, or let's say much more defined.
Yeah, so imagine we have some input query, some input request that says, show me costs using some metric. And when we use this metric, the way we calculate costs is by taking prior costs minus current costs, which is counterintuitive. Usually it would be current costs minus prior costs. In our instructions, let's say we represent cost change as current cost minus prior cost. So that's incorrect. We produce an incorrect generation. And then with that feedback, we can look at those instructions and say, did this feedback come from these instructions? And that in our instructions, are we representing cost change as prior cost minus current cost, or current cost minus prior cost? If it's incorrect, then we pass it to a model call, have the model correct those instructions. Same is true of the examples. If in the SQL we're representing cost change incorrectly, we can detect that incorrectly.
Oh, thank you.
Yep. Please.
So in a corporate setting, they're basically access control, right?
Yep.
Database tables and stuff like that.
Yep.
I'm not sure how.
Yeah. So at the pre-processing level and at the post-processing level, we have these guardrails that check for the user controls, which data they can access, which data they can't access. The user tries to access data that they don't have access to. We have guardrails that say this is outside of the limitation of the.
So the same question could be answered by joining different tables based on your access control, right?
Not so. The query intents that we define are very narrow in range. And so the structure associated with a particular intent or a particular query is likely to always use the same tables, same columns, same calculations, so on and so forth. And this is this is part of the reason why the approach works as it does, is in that we make our examples, our instructions, so on and so forth, very uniform in structure. This uniformity restricts the probabilities associated with the potential responses to only a very narrow band of potential query generations. And so, yeah, does that answer your question?
What wasn't clear in your answer was the following. You have 20 tables, and the user only has access to 3. There's 2 tables that are very crucial for their query. They don't get transferred. How do you do access control across the whole pipeline?
Well, I would imagine that that would be captured by the guardrails, in that we can tell that this query needs these 3 tables. The user only has access to these 2, and as such will restrict the user's limitations. Yes.
Breakdown.
So I have a question about the self-correction part. So you use the error message to guide your next round of instruction and create the new thing, right? Like, you explain a bit more about how you go about using the error and modifying your query, and at what point in time, there are sometimes it's not gonna converge, right? At what point in time, or what threshold do you use to give up? Yes.
That's a great question. So let's say we get an error message that says this table does not exist, or this filter does not exist for a particular query. Then we'll pass that error message with the original query, the schema, the instructions, everything, to regenerate that query. The model can handle that pretty well, actually. However, if you see here, we set the limit to three regenerations. Just for the user experience, we don't want the user to sit there for 2, 3, 4 minutes. So after 3 generations, if it fails, it will be marked for review by our team, so we can understand why that query failed. And then we'll pass in that feedback here. You could also think of this as either user feedback or team feedback. Provide that feedback, we update the system accordingly.
Yes, the last question.
I can just shut up.
Oh,
So I have 2 questions. First one is about like between the transformation or between the mapping between the natural language and SQL language. So is there any gap between these 2 spaces?
Yes, of course. So let's say, for example, the user provides something like PM costs, which are per member per month costs. They provide that in natural language as PM costs. The way that would be represented in SQL would be like some costs over some members. And so there is a fundamental difference in the representation of the information here. That on the left, we're talking as per member per month cost as a single entity, whereas on the right, it involves one.
Then in some cases, the mapping is success, and then the problem cannot be solved. For example, the user asking for what's the weather tomorrow, and then it cannot be answered by the query.
Yeah, absolutely. Absolutely. So this is another case for guardrails. We have relevance guardrails. We have data scope guardrails, so on and so forth. So these guardrails protect against, let's say we define the limitations of the model in these guardrails, such that if someone asks, what's the weather in April of 2025? Say, well, we haven't gotten there yet. The pre-training of the model doesn't know this information. We might answer this question, and we'll give a suggestion for how they could reformulate their query in a way that is supported by this.
My other question is on the cost. So you mentioned that the cost of time does not matter here, but I'm wondering what's about the cost of money?
Yeah, absolutely.
Money scale with the
absolutely. So this is a great question. I never said that the implementation was cheap. So it is not cheap. Most text-to-SQL implementations are not cheap. Current offerings range around 90 cents to $1 and change for a particular query. Ours is somewhere around this range, maybe a little bit more expensive, but also we have better accuracy than those out-of-the-box performance. So it will be around $1 to $2 per query requested. Yep. Also, I should mention there are things you could do to combat costs that we don't do here because we are told to optimize for latency and for accuracy. But if you want to optimize for cost, in the same way you retrieve examples associated with a particular intent, you could imagine that a particular intent class has queries of much simpler structure. And so for those simpler structures, you may not need a GPT-4 0613 32K, but instead you could use a GPT-3.5 or GPT-4 Omni or whatever it may be. So you can use a cheaper model for less complex cases.
Fast.
Thanks for the great presentation. I was just wondering if you could say a few words about the cases that you're stuck this on.
Yes.
Cases.
Yeah, absolutely. So maybe I'll reframe the question, but I will answer this. Okay. So the general text-to-SQL problem, if we were to use a benchmark like Spider or Bird or any of these benchmarks, assume that we have a lot of databases, we have maybe a lot of examples, we don't have any extrinsic knowledge. And so if we're solving for those general benchmarks, we're solving for a different problem entirely. We don't need instructions, we don't need to encode information about the extrinsic knowledge in the example, so on and so forth. And so the fail case in either this or any case where you have to include extrinsic knowledge is that you haven't encoded this information into the examples or the instructions that you're working with. And so we'll end up with a failure at first for such a case, But the hope is that we update the system with feedback such that the next time around, this extrinsic knowledge is included in our knowledge set, so we should be able to handle it. Yep.
Thank you. So I will ask all the panelists to please come and sit with us.
Thank you.
I'm gonna be the moderator.
Yes, I'll.
So can we pass this around in the audience and we'll just use.
I think that would be easier, right?
Yeah, yeah.
That's the.
I just changed.
Okay, excellent. What about this?
This one.
Okay, so.
Sure, yeah, I can.
Okay, so before moving forward, I just wanted to briefly introduce Amelia, who's joining us.
Sorry, like they can't hear you.
Oh, you can't hear me? All right, thanks.
Hello? This wasn't me.
Oh, there's an out there.
This was just need to check.
Oh, hello. Is it working? No? Good. Okay. So I wanted to introduce Amelia, who's also joining us for the panel. He's an ML engineer at Desjardins. For those who are not Canadian, is one of the big financial corporation in America. So he's working on offering modern ML workflow for cloud platform, basically in finance industry. And he works on building and shipping ML enabled solutions to provide trustworthy results to the customer. He's also one of our he got his master's from Polytechnic, so we're very happy and proud to have one of our graduates with us. And to moderate the session, we're honored to have Diane with us. It's a small change of plan today. So he's a principal researcher at the Center for Software Excellence at Huawei Canada, leading the research on software engineering for AI-based solution. His reputation actually sees, so you don't need further introduction. Yeah. Okay. So I'll leave it to you. Maybe I'll.
I can put next. I can just use this one.
Thanks.
I think we'll pass that one in the audience, right? So yeah, just because we know there's a working microphone. Yeah. Okay. Let's pass this in the audience. Hello, everyone. I know I'm the only thing standing between you and dinner or reception or poster. So let's hopefully we can spend the last hour of the day in a productive and informative way. We have a great panel here to discuss about the trustworthy engineering of foundation model or machine learning powered systems. So I'll just start with some very general quick questions, and then I'll try to leave as much time as possible for the audience to ask questions. Okay, I think we already have an introduction of all the panelists here, so I think we can directly start the discussion. So I know when we're talking about engineering trustworthy system, a lot of times we'll start by saying what is the definition of trustworthiness in this kind of systems. I think we have had a lot of discussions in all the past events on this. So I do want to start to talk about what is engineering in this case. What does it mean to engineer a trustworthy systems? What would be, in your opinion, the biggest challenge between just building a demo of this kind of system versus building a system that can actually run in production for these kind of systems? You like to say?
Sure. So when we think about trustworthiness in these systems, we can think of it as an umbrella term, capturing many other properties like fairness, autonomy, transparency, data security, so on and so forth. So if we think of this as a weighted sum of all of these properties, the problem in building such a system is understanding what are the weights associated with this weighted sum for your particular application and your particular domain. So let's say, for example, I'm building an application for text-to-SQL translation to identify the top basketball players on the Toronto Raptors. Then in this case, something like reliability might be more important than fairness. Instead, we're trying to disperse loans, it's like fairness might be more important. And so there's this step at the forefront, or at the pre-processing stage associated with determining the trustworthiness. That is understanding the domain, the context, and then you can build around that. There are 3 stages we generally use to build around trustworthiness. These are at the pre-processing level, the generation level, and the post-processing level. So you could use guardrails at all 3 of these stages. And to make your system as trustworthy as possible, we tend to use programmatic checks whenever possible for our guardrails. But in general, as I said earlier, you can also have this sort of relationship where you have a model that is an expert. The model is sort of tutoring this intern. So you could create a model that is a sort of expert in a particular guardrail, have that model guide this overarching system towards proper behavior.
I guess, condemnation or trustworthiness, we have a really lot of discussions. I think we generally can classify the property into functional and non-functional property, and non-functional in terms of the thermal correct of the model, and non-functional by the ones of the certainty. I feel that one thing is missing is probably we need to think more about the honesty of plans, because we have now entered a new area with like function models. So previous models we don't need to care about. We don't need to worry about when those models demand to us, whether we follow our orders or not. But that's with non-functional agents, we probably would face this issue very soon, right? Whether they are honest with us, whether they are secretly doing something with them, or next to each other to destroy crazy ideas like that. And for engineering ones, I feel that the big challenge is that if you want to improve it, you have to first know how to measure them. And for lots of non-functional properties, we actually now have an issue of knowing how to measure them. Even if we measure them, we have, like, for example, for fairness, we have different metrics and which metric we use, so they have a conflict, so what's our choice, and so on. So there was
from the industry, what I see more is that I think requirements engineering plays a big part of how you define the solution. Like, when people knowing what they want is already a challenge, but especially in the age of something that can just generate anything to you, that becomes a bit more difficult. One key thing I think is to define, like, to have a trustworthy engineered system is know what the boundaries are. Like, I love reproducibility, but like in the definition of reproducibility, there's the concept of knowing that within a stated precision, you know, the results. So in the sense that for my stakeholders, I need to be able to say, well, the system will be able to answer up to this point. And what we'll be able to do, that's where we need like the guardrails that you mentioned. And another aspect I think for trustworthiness is, like, of course, the security part of it. And for that, like, there's a lot of security concerns, and confinement we found is one of the biggest helps here. And I think also legal, even legal aspects of how the data is treated, that's a big one. So it's all about, like, I think someone said labor protection. I think like the onion of security is also a big thing that needs to be incorporated to ship something into production. Like, yes, a demo takes like 5 minutes to make, 1 day, 1 week. But like actually deploying to production, it takes a lot of time just to get the boards, the data residency agreements, and just like the confinement of the systems and assessing with tests. And I like to do end-to-end tests and show that to the stakeholder. Here's what you're gonna get and what's extreme. So.
Okay, I will touch with the engineering part. Right? So the point, I guess, what exactly does engineering mean, right? So the problem right now in the industry is like, the industry is like, you have a superhero, right? So if you have a superhero developer, then you can achieve a lot of this. But a lot of times, the average developer is way average, okay? And now, how do you actually make average developers perform as powerful as these super developers, right? And it really comes down to getting the right processes in place, and as well getting the tooling to support these processes. So that's an example. Like the people we work on, actually, we spent a lot of time on this. What exactly is the post development cycle software? what are the tools that need to develop this kind of software? Because otherwise, yes, if you have a super developer, they can just write everything down in assembly. But these people cost a lot of money, they don't exist as a system.
Thank you. I might want to add one more question, and then we'll open up for the audience. So I think the panel has brought up a very interesting point about testing quality assurance before releasing to production being a big issue, right? And then also in the talk that everyone gave previously, we also talked about there's a balance between how much cost we understand or how much consumption we allow the system to have versus the quality of it. So do we see these aspects in quality, trustworthiness, cost consumption, energy consumption conflict with each other, and how do we balance that?
Well, in our case, it's a bit easier because there's like a will to actually test the solutions. But I guess like it depends on the industry. In the financial, there's a lot of regulation, and you need to be able to say, hey, this is the answer, and you would rather spend like 10x the effort on testing, even though it might be a bit more difficult at first, but will evolve. So it's a price to pay that at the moment is kind of what we're doing. But there's definitely a lot of testing that goes.
There's definitely a role in terms of the code and also, for example, how much money for a company they earn. And we can see what's already happening inside OpenAI. We can see the conflict to the previous chief scientists and also the CEO Sam, right? And they left really because their super alignment team, they couldn't get enough funding. Couldn't get enough money from OpenAI to do the alignment work to improve the trustworthiness issues. So it definitely needs a lot of money, and I don't think even OpenAI, they promised a lot on that, and they're like constructing a lot of the tree walls.
I would add, even on a smaller scale, like if you take say a particular enterprise that's concerned with a Q&A answer. So, I'm not talking OpenAI scale here, but smaller scales. Trustworthiness, and not happy to say it, is in some ways pay to win. You can ask a model, for example, to generate a response, and with that response, you provide the reasoning associated with the model. Now, even though the reasoning is provided, the model can provide improper reasoning to justify the improper response. But then you can imagine passing that reasoning to another model and asking that other model, is this reasoning reasonable? So that second model will likely not fall into the same trap as the first model. And you can just keep chaining this forward. And there are a lot of these sort of layered, as you put, approaches to trustworthiness, QA that we can take, but they are very expensive as well.
Yeah, so again, so that the reality is nobody can make money to build a whole software system on before. So the cost is too high to make money. So the question right now is how do you actually still deliver a good enough product without the, and this assumes before it's actually good. Which a lot of times it's not the case. You have to go on more patching around it, as you mentioned, adding more complex architectures, deal with this. But then now when you do that, then you end up with there's a lot of cost tokens and these chatter going around all these agents to give you, you ask a simple question, and that question is followed with many agents and all these discussions, then it just takes in and kills people. So a lot of times on the outside, the AI folks are doing all this fancy stuff. But the reality now, when these are cracking real systems, just they don't scale. Like for example, I think the biggest thing right now is this unlimited context for large context. Like that just, it's like pretty much having a car which can go up to 300 kilometers an hour. It's useless, okay? Because the problem is the reality of the laws of physics, you need to move data. Okay, so every time you ask a question, you have to move all of Wikipedia and put it in front of the prompt. That goes all the way to the capabilities of the model, right? It's just,
So here we're between this, I would say there's basically two worlds, right? So there's like this super open AI kind of AI folks, and this kind of the system world which says you need to pick the right model, sizing the right models. And really, it's very important to design the systems. Now, the problem is we're all learning how to design the systems today, and we don't know what's the best design or the best.
Awesome, thank you. Now we're gonna ask the audience to ask some questions for them.
Hi, my questions following the conversation that you guys are having, and we have to distribute them to a treatment, right? So in industry, especially in financial industry and a complex machinery like yours, how do you go about testing? And what does a quality assurance for these applications in industry looks like? And from an academic perspective, what do you think needs to be done more in relation to this development?
In our case, it's a lot about multiple rounds with the stakeholders and some users at first. Most companies, I think, are testing things internally at first, and that's what we're doing. So within one of the systems that we're developing, there's like, I don't know, 50 people in which that they interact with, like, each week changing, well, the models and their prompts themselves. So it's really about showing to the end users what they will experience. And so I think that's one of the key aspects. It's just fast iterations and fast show of value. And afterwards, there's also a lot of other things to test that we also do, which is also like, we replace, to measure the fairness, we can replace the words like, hey, if someone asks, is it a man, is it a woman, like the examples that we saw before. And that's something that we also check within the pipelines that we write. So each time we ship a model, we always run these pipelines. And I think automation is the key here.
Yeah, so when we build a pipeline, like I was showing earlier, the process of evaluation is incredibly painful. And then we want to evaluate every component of the system, not just the system at large, such that not only if, like, let's say we have a model change, we want to make sure that schema linking, for example, continues to work as we use GPT-72. And so we'll construct these handcrafted evaluation sets, but we allow the models to reason about the correctness of the result. Because you could use fuzzy matching and other things as well. But by allowing the model to reason about the result, you can encode this contextual information that will allow the model to reason about correctness in cases where it's not obvious, an exact match or fuzzy match or whatever. For example, if a user, or if the output includes an acronym, if we do some sort of fuzzy match, we may capture that, but if we include the contextual information associated with correctness for this acronym, then we can capture it. And so that was a long-winded answer. The short answer is handcrafted evaluation sets, model-based evaluation.
I will answer the research side of that. I feel that for testing, either we rely on benchmarks or we, design real time testing, like design testing for technique. I think for benchmark parts, I heard a lot of complaints from industry guys that we these benchmarks are not really safe, and basically couldn't use them at all. Which means that those benchmarks just for research purposes. For really validating action level problems. So I hope that's something that research community can focus on. But the big challenge is that to whether this benchmark with data really vibration with the industry. So I feel it's also a good question, like how academia and industry can collaborate together to provide more for the real-time testing and development area and but good thing is that software testing we have lots of automated expectation gains. I believe that will contribute a lot to that.
I'm going to be a very academic one. The question was, well, so when mobile apps came up, right?
I think there was a total different shift to what's called. And then it comes down to, is this app not good enough for your will uninstall it? Right, or you just good enough, better enough than your computer, right? So that's one thing. Second, in this type of software, we actually don't expect the software to be right all the time, but we expect that as we interact. So, you know, if you have an intern and you ask them to get you coffee and you get you know, from Starbucks, but you like Tim Hortons, the first time you will forgive them, but now you tell them to like Starbucks. So the next time they don't get it from Starbucks, then you can Starbucks that app, right? So as that was, this is quality is becoming a very big term itself. Okay, so versus kind of how you actually find quality, what's tracking the quality over time and actually get a feedback loop, right? A lot of these VMwares today have some stuff that sell, track what you copy the data, and then we feed that back in. Now, the problem is was that feedback in, we've already seen where it can get backfire. So you know, the last year we were saying the ChatGPT become dumber and easier. Well, the problem becoming dumber and easier because it's actually becoming as good as the average human. Okay, so the human, he can give you the right answer, but ChatGPT, if you give it 5 stars, just well, if humans make this good, then I'm going to become at that level. So the whole quality assurance is becoming much more complex. At least from my perspective, I think a lot of things about metamorphic testing looks very promising, but in general, over time tracking their quality is actually becoming very essential because it's changing. Even if everything is fixed, just people's perspective and expectations are changing. People's forgiveness of software being wrong. We're basically treating software as human. And we're very more forgiving to humans.
Thank you. I think there's this one here.
Thank you so much. My name is Kasim Sadiq. The question I have is about this whole topic of trustworthiness of AI system. So there are so many metrics and standards that exist, so many published articles about the fairness, expert AI, and rest of them. So based on the panelist members, the question I have is, assuming that you have a grant, 500,000, and you can only use this 500,000 to sponsor a research project that is going to improve or address a gap in trustworthiness of AI. So with this 500,000, what are the topics that you're going to ask professors to work on there? And you also have the 500,000, you have the professors that you can work with. What should be the research topic? Because somehow to me, or maybe to other students, what are the current gaps in this space of trustworthiness? Maybe in academia or in industry. So with your expertise level, can you tell us what we should focus more to address? Given that you have money, what should we ask us? Thank you.
Yes, my answer is going to be biased to my experience, but the majority of the tokens that we spend in any of our approaches are around reliability and honesty. So if we had a model that could honestly say when it doesn't know the answer to something, it would make our lives a lot easier. And it would allow us to both debug the systems easier, but also construct the systems easier by knowing the limitations of the capabilities of the model. I'm sure there are much more pressing answers around fairness and so on, but I probably not the guy to give the answer.
Yeah, so I think this thing about preventing it from hallucination is becoming very common. Again, a lot of the ways today is basically trying not to force it in the corner where we're interested. So that's one. So like basically go and ask it a question where, you know, if it doesn't know the answer, there's a high chance to lose. And I've seen some approaches today that actually would say, you know, they will put in a prompt at least one answer to the question. Okay, such that you know that The GPT model itself finds an answer, so it doesn't force itself to hallucinate. And then when it finds an answer, you say, okay, well, if it found that answer that I put in and I know it's the wrong answer, it actually didn't have an answer. But as soon as you ask it something that doesn't have an answer, there's a higher chance.
I would say that one aspect that I feel that we 1% sustainability is how we look at apps. It's really against current evaluation that it's a lot of cost and also nowadays one for engineering strategy, the total overhead is keeps increasing and only more data is right? So how can we reduce the cost of training ads and also reduce the cost of the in terms of money or overheads? And when we use one for agents, how can we get them quickly reach a consensus with the fewer costs or that was reducing costs is definitely that's very demanding.
I think there was a question on the other side, right?
Yeah.
Oh.
Since this morning, I haven't heard about the carbon footprint of the model of development. It's a big concern, and how do you see the future right now? Because especially for large number model, very carbon emission aware. And for me, it seems like we close our eye on this aspect of development. I think the way we should go now is to think about embedding this type of awareness into the whole life cycle of development. What's your thought on this?
So I never use the word large language model. Okay, I use the word foundational model.
What?
Because the large is not the big point. Okay. So we already have seen, so Microsoft now has the Phi model, which is a very small model, and performs a lot of things as the big model. So that's one. And second, the language part, we're beyond that, because that would be the picture, right? Foundational, that's exactly. So I decided at the beginning, I don't want to update my slides. Okay, so I'm doing reuse and recycle, okay? So green guy on that too. But basically, I think that the key point here is that it's all about just engineering design, right? And that's again the importance of strong engineering and design principles as you're doing this. Yes, you can bring this thing into the room, but you really need to bring this thing. And then if you have to, even if you have access to these things, the latency issues, power consumption issues, all of that kind of like this, right?
Yeah, like for a lot of solutions of the problems, I think standardization is kind of the main end goal here, because a lot of these, like say newer technologies of the years have all been constrained to some extent with standards. So we have a way to operate at a nuclear center, certain protocol, etc. So I think when it comes to training and using large language models, there will be a point where we just say, hey, if you want to infer this kind of data, well, we're going to output you the carbon emissions that it consumed. I think there's a lot of cool projects already for measuring the carbon emissions from language from any model actually. So that could be something that is intrinsic, like that's actually built into the inference platforms. And I think there could also be maybe some information that's given when we train these large language models or any foundational models with respect to carbon emissions and other things. So I think it's just more of a process of standardizing and saying, hey, if you want to use your model, you need to measure. And I think it's as simple as that. But it's hard to understand.
I think one important use improve awareness of that, is that when we compare models, we really also compare their size. And I can now see that there is a trend with that, with the whole reports, number of characters in the model and also their largest is on their loss of any characters. Okay, so there already is change. One possible solution to reducing the cost of I see that don't overly rely on those general items like GPT-4 can do everything for us. So we can have more small size special purpose tools for local generation. That's one way to control costs, of course, very difficult.
Our most recent research, from Ericsson Canada, our most recent research is not seeing any alignment between the parameter size and the accuracy you're going to achieve in the same condition. I think there's another trick to come out with. I don't know exactly what we need, but our investigation, our study is showing that it's not really aligned. As your model is large, it's not NPC showing that we will have good accuracy, right? And it depends on some maybe other parameters, context. But our study showed that it's not a work remaining to be done.
Yeah, that's true. I think, I think those numbers, but we will get more like one or optimized. So that's all around.
Thank you. We can probably take one more question from the audience.
Thank you guys for very interesting talk. So I teach test-driven development, and I'm a bit biased about regression testing. And I also work with software coaching, and so I'm just wondering with this LLM-based software development, what is the thought about the change management, let's say, in this kind of LLM-based application? So you talked about, I think Amit talked about metamorphic testing. So what will be the, let's say, regression testing equivalent for machine learning application? What do you guys think?
So the question is, what is the equivalent of regression testing for large model applications? Right?
I guess I can talk about our deployed text-to-SQL solution, the way we tested that. So we have versions of our deployments, and so we'll roll out to groups and iterations. With those deployments, we have evaluation metrics based on those rollouts. And if we see for a particular rollout that we've scaled back in any way due to feedback from the users or feedback from the model, then we can go back to the prior version. That's the first thing that comes to mind.
Yeah, in our case too, I think the most important part is building that golden data set, and then like once we roll out a new model, right, we still check like, hey, what's the relevance of these new answers, these new outputs in comparison to the golden data set that we have. So if the relevance is really out of distribution compared to the previous one, we can say, hey, there's a shift, so you probably did a regression. And I think that would be close to the equivalent. It's akin to what we're saying, actually. So it's all about just like testing with a golden data set for us.
What right now the challenge with regression is if your system is using GPT-4 example, right? So or whatever, any external system, right? Now you do a check-in. That check-in actually costs you $2. Okay. So now if you're a large company and there's 1,000 check-ins, that's $2,000. Well, right? At least the things I'm seeing right now is people trying to get some caching later. Okay, to try to just avoid you actually getting right? So that's like one of the things. The second thing as well is when something breaks, figuring out what broke is another challenge. for companies that are using like just traditional, like smart basic classical ragware kind of, promptware, it's not as complex, but once you have multiple agents, because 6 agents are talking, one of them said something wrong. And then he found that, after 10 people talk, after 10 agents talk, how do you actually figure that out? Because there's no code, there's no tracing at all of it. So regression testing will exist, but it needs to be totally default in this world where actually every run costs actually real dollars.
Thank you. So, okay, fine, last question.
Ahmed was mentioning about the engineering. When we talked about the processes need to be taken place in order to accommodate these new technologies. So do you have any thoughts? Like now we are following as a software developer. So do you think any alternative of agile software development?
The answer is I don't know the answer. Okay. And I think that the key message really get out of this is whether myself or everybody needs to, we all actually try to learn this, right? And I think the key point we want to highlight is this is a totally different way to develop software. It's a totally different type of software, and it's gonna be a big part of software development, right? And if you're a student or an academic in the room, it's important for you to kind of wake up and be part of basically the future of software. Now, that doesn't mean that if codeware is going to disappear. No, codeware will exist, but that will exist. It's the same way that people still write, what you call it, embedded software, and then you move on to web software, and then they move on to mobile apps. All of us are going to exist. So this is not the end of codeware and the future is AIware. But more and more, this AIware is being able to develop much more complex software, and it's becoming much more the kind of expectations of users. Users now expect software that can actually talk to them in a friendly way. In the old days, we were happy even if the software had doing it, but the expectations are changing.
So as it comes to the processes needed for engineering the system itself, like Agile we were mentioning, I think it needs to be just a bit adapted more for the requirements of managing installations more than anything at this present moment, that I think there's a lot of hype and nobody thinks the system can do anything. So for the requirements and planning, I think it's just about managing expectations and everything. About the actual technical engineering, I'm a big proponent of measuring everything, having experiments for absolutely everything and being able to deploy multiple versions of multiple models at the same time, then just do some shadow testing. And I think that's the kind of discipline that needs to be there, especially when in an age where everything is so experimental. So we need logging of pretty much everything and seeing how a model performs with another. So I think that just logging the experiments and just measuring them is a big step. And it's more about rigor and engineering rigor and scientific methodology.
I agree. I think the alignments procedure will, take a lot of time and cost. So I'm not sure I can see.
Just in terms of two things that I think would be super valuable moving forward. One is some sort of prompt tuning framework. This is something I think you brought up, but in general, there is a lot of time and effort wasted on swapping around carrots for pound symbols and so on and so forth. And so having a way to very quickly do that and see the results would be valuable. On top of that, I would say some sort of data tuning framework. So in the text to SQL presentation, we were showing that the examples and the instructions and all that stuff go into the prompt. And so in effect, we are sort of tuning the prompt by changing the examples, but having a way to more easily be able to alter examples to say, I want to show the examples in this form, versus this form, versus that form, see how it affects performance would be really valuable.
Do you see any change in the team dynamics, like, as you know, when, it involves machine learning or model development, which requires a lot of collaboration. Research shows that, this collaboration actually, actually cause a lot of communication loss. That you need to interact with, different types of, engineers or stakeholders. So do you foresee like there will be massive change in terms of team dynamics or team
Yes, we see a lot of changes that have actually we live in at the present moment. I think it comes with the new role of what we call like ML engineering. That's kind of new, but not really ML as much ML ops. But we do see that there needs to be like a new way of working together, and we shifted from projects more to team-based, multidisciplinary units, rather than before that was more like we have the analytical side and then we have the IT side. Now it's all mishmashed together and doing the same work on the same things. So I think that helped us a lot. So yes, it's definitely change needed. But as long as you have like good communication and a really fast development process, which Agile can help with, I think.
So there's two types of software, right? So there's codeware and AIware, okay? And then now on top of both of them, there's basically AI first. Okay, so now you have an AI helper, right? Now AI helpers are really amazing actually for young developers. Because basically, as a young developer, you're too shy, you don't want to ask your boss the wrong questions. You can always ask the AI. Now, the AI could go wrong sometimes, but your boss is wrong a lot of times. Okay? But what ends up happening is over time, the dynamics of like what's building relations with people actually drops, right? So you don't remember, well, this is the person that mentored me going into the team. So that relation kind of disappears or has, right? So the trust relations in these development teams is becoming very interesting dynamics. I don't know where that's gonna go, but I think it's a big problem and it doesn't help as well now with remote development too, right? So at the end of the day, everybody you're talking to is an AI. Then now when you want to leave the job, who's gonna write your reference letter, right? So yeah, the dynamics here, it's very complicated interactions moving forward. Now I think this is not just only for software engineering, throughout the whole industry as AI becomes like a true partner teammate.
I think there's one difference also, video collaboration or team collaboration is that, we make, or have agents, so instead of having the different collaboration with each other, maybe that is our agent assistants collaborating with each other, so I think that's usually, to explore how agents aid to ask each other and they collaborate.
Okay, thanks everyone for staying till now, and I think it's time to wrap up the panel. Let's give another round of applause to the audience. Yeah, let's conclude.
So the poster session and the reception will be at